unmute. Did you say Maria Elena?
Maria Elena.
Oh, Maria Elena?
Yes,
Because
it's so when they together it becomes Maria Elena, but when they're separately they're Maria Eleni.
oh,
So it's just like my official is Maria Eleni, all first name, but to separate. But everybody calls me Maria Elena as one. But the I becomes A. I mean, complicated.
oh, so pretty.
I know, right?
Well, and people are just used to referring to me as Maria, and maybe a long time ago I should have
Put it. Yes, yes. You can start now.
because
Why not?
nobody in my family calls me Maria. They all call me Elena or Elena.
See, yeah. So yeah, I love it.
All righty. Okay, so we're going to go ahead and start our 1 o'clock after lunch first session. And I'm going to just turn it over to Maria Elena.
Perfect. Thank you. Hi, everyone. Thank you, Maria. Wow. I just want to start by saying that I'm learning so many things today. So my name is Maria Elena Christopoulou. I'm an oceanographer. I work at SBE for the last 1.5 years approximately. So I can tell you already that most of you have way more experience on like using the 9/11, as part of your work. But I'm very, very happy to be here. I'm very happy to present you some things about the 9/11 system, some things that Seabird wants to recommend to users, to all of you, and some things about data processing, collection, setup of the equipment, and above all, I'm here to have an open discussion with you. I'm happy to take questions as long as you're okay with me answering. I don't know the answer to that, and being able to come back to you with the answer. So yeah, a little about me, about my background. I'm from Greece originally, and I did my bachelor's and my master's in Greece. And then I came in the US to do a PhD in paleoceanography. So I have also some background in geological oceanography, but life makes cycles, and I'm back in the CDD world. And yeah, so let's keep it interactive because it's post-lunch, and I think we're all like getting a little, maybe sleepy after lunch. What do I do? Okay, so I will give an overview of the 9/11 system, some characteristics of the sensors. Bear with me, I know most of you know almost all this information. I will talk about a few things when profiling, some tips, some configuration schemes, some deployment tips that we discovered in our recent communication with a lot of customers in Europe. We discovered that there is so many different approaches of how to deploy the 9/11, a lot of different perspectives. And I'm here not only to tell you what SBE recommends, but I'm here to listen what you do and what works for you best. And of course, then at the end, I'm going to talk about some the post-deployment time, where I'm going to talk about data processing, caring for your conductivity cell, and I'm going to also mention, we're going to talk about the new software that SBE is going to release. It has released already. We are incrementally adding new sensors. So we have already added the 19 plus, we have added the moored instruments, the 37, and the 9/11 is coming. Of course, it's a big instrument, a lot of things behind the 9/11, so it's coming. Okay. Well, I don't think I need to say a lot about it. So this is the 9/11 plus, 9/11 plus V2 profiling system. It's SBE's flagship CDD, of course. It's one of the most widely used CDDs in the world. The 9 plus is the underwater part of the system. It houses the acquisition, telemetry, power supply circuitry, The 9 Plus receives power from the deck unit, the 11 deck unit, and can operate over 10,000 kilometers of sea cable. It can operate also several types of water samplers and may be configured with a serial port multiplexed into the data stream to accommodate instruments with serial output rather than the traditional voltage or frequency. It comes standard with pressure, to temperature and to conductivity channels, and 8-volt voltage channels for auxiliary sensors. Oops, sorry. Okay, let's dive a little bit deeper into the components of the 9, right? So we have, it comes with modular sensors, as we already mentioned. This is good, very helpful because they can be calibrated separately. It comes with a thermistor-based temperature sensor and a secondary, which is optional, a conductivity sensor with an internal field and secondary as well, optional. The pump, the 5 pump that controls the flow within the system, that we're going to talk more about it later. A DC duct, which is basically matches the response times, making sure that everything is measured in the same parcel of water, very important for derived parameters like salinity. And of course, a high accuracy and very stable DC quartz pressure sensor, which is inside the housing. This is a SBE4 conductivity sensor and the SBE3 temperature sensor. The pressure sensor, which is typically internal again to the main housing of the CDD, has also a small temperature sensor that compensates for any temperature effects for the pressure. Okay, let's take the sensors one by one and describe some of their characteristics. The SBE3 is a thermistor-based sensor, which means that its active element is a thermistor that changes its resistance with the temperature change. And this is translated through an oscillator to a change in the frequency, which is the final output signal. The SBE3 has a very fast response time of 70 milliseconds, which means that it can resolve very, very fine structures in the temperature throughout the water column. Our SBE4, our conductivity cell, which is an electrode-based conductivity sensor, which means that it's a glass cell, a borosilicate glass cell that has electrodes inside, that a current is generated, and then the electrodes, anyway, without going into much technical detail, the electrodes measure the conductance of the seawater that flows through the cell. The accuracy of the measurement depends on the geometry of the cell. So the volume needs to remain constant throughout the water column while profiling. There are things that have to do with biofouling that might change the volume inside the cell, but we're going to talk about it as well a little bit. But also the pressure effect of the conductivity cell when we go into deep waters and high pressures is corrected inside the Siebert's conductivity equation. So there are coefficients in the conductivity equation that correct for the effect of pressure. Because again, it's very important the volume of the cell to remain constant. It's necessary for accurate conductivity measurement. Sorry. Okay. We talked about the TC duct. This is how we ensure that the temperature and conductivity measurements are made in the same parcel of water. So here is a diagram showing exactly how the water is plumbed through the system. The water parcel first passes through the temperature sensor and moves through the TC duct to flow through the conductivity sensor. I forgot to mention earlier for the conductivity sensor that the response time of the cell is flow dependent, and it's a little complicated math behind it, but at Siebert we control the flow rate, so the response time of the cell matches the temperature sensor. So the TC duct, again, is the system that ensures that the temperature and the conductivity are measured in the same parcel of water. This design makes sure that effects of seep heave is minimized. And because of this constant flow rate and this very smooth flow rate, any other data manipulation, post-processing, filtering, and other data processing is much more successful and easier to be done. I also forgot something else about the conductivity sensor, that the internal field is very important. Again, that the fact that conductivity is measured inside the cell and not it's not an external field, because these conductivity measurements are immune to external factors, anything that's happening in the water column. This is a very important advantage of the design. So far, so good? We're good? Oh, okay, so these are caps, the top and the bottom. I don't think that we have to go into much detail about the end caps. And Marshall earlier talked about some things about the uplink and non-uplink, and I will mention that. Just I wanted to show a schematic of the end caps with the different connectors. And all seabird CDD profilers come with, as a companion, we have also water sampling equipment. The 32 is one of the most widely used again. Seabird manufactures the framework, the mechanism for closing bottles, and the power supply and sampler control. The water sample bottles are not manufactured by Seabird, you all know that. The SBE 32 basically is the portion of the equipment that triggers the bottle closure. The carousel trigger mechanism is an electromechanical device. It operates by energizing a solenoid magnet that pulls a mechanical trigger, releasing the lanyards that hold the top and bottom caps of the water sampler open. For the 9 plus, the 11 plus, the unit provides real-time water sampler control. I promise I will stop. That's not the microphone. Okay, so in the 11 plus, the unit, which is the unit that provides power and telemetry to the 9 plus, it connects directly to your computer, where real-time data is archived using the CSAFE software. And again, here I want to mention that Seabird is in the process of developing. We have developed it, but we're in the process of introducing new sensors every time, very often to the Fathom software. The goal is eventually the Fathom software to replace everything. So to be used for everything: data acquisition, data processing, plotting. And actually, I would like to tell you all, if you have 19 plus or if you have 37s, to go ahead and download Fathom, start using it, process your data, and contact Seabird tech support, myself, or a software team, and just, hey, Seabird, that doesn't work, or hey, Seabird, this is very cool, thank you. It's very important for us to know what is no longer with the old software, what makes your life harder, and so we can make your life easier. So the 11 plus unit, GPS can be connected to the box for integration with the CDD data stream. And what Marcel mentioned earlier about the uplink and non-uplink, I think Chris mentioned that during your communication, that the deck unit can be modified to communicate with both uplink and non-uplink SBE 9 plus. So a question I have here, and actually this was brought up in our trip in Europe recently, because a lot of universities have pools of instruments that they don't have like a 911 with a carousel in one SIP. They have pools of instruments, and they have to put together for every expedition different components, like a 9 and 11. And it has been a case, for example, that it was not very clear that you cannot mix and match an uplink and a non-uplink. While the 11 plus can be modified, the 9 cannot be modified if it's uplink or non-uplink. This is it. So if you have an uplink, which is a way to transfer serial data, if you have an uplink 9 plus, and you have then the 11 deck unit has to be uplink as well, and vice versa. How do you know? So a quick way to confirm is identify the JD4 connector if it's a 3-pin or 4-pin, and the non-uplink, which is I think most of Seabird 9s, is and it has 3 pins, and uplink has 4 pins. Right. Yeah. Then for the deck unit, flipping a deck unit upside down and opening the panel, you can see the jumper position. And this is where you can modify, actually, if you want to modify the uplink or non-uplink version. And lastly, another way to know is the deck unit will notify with an error code, as discussed earlier. This could be also a case where you'll get an error code. Although this error code can be for several other reasons, this is something that it's worth double checking, right? Since we had this comment from these users in Europe. Okay, now the fun part, when profiling. Did I have a little notes here? Okay. Yes.
So can I 11 be, weren't on 11, can the 11 be modified at C to make it uplink or non-uplink just by a jumper?
Yes, you can open it and you can modify it as long as it's, careful. Yes, Marshall, please feel free to jump in and correct me wherever.
Okay, thanks.
Can you repeat? Yes.
The question was. Switching. Just pointed out, I believe there are earlier, I'm certain that there are earlier Seabird 11s didn't have the uplink feature because it didn't exist, but they're still usable like Seabird. And so just simply check with Seabirds and that's support. If you're serial number,
yeah,
provide a whole serial number and model.
And label it on the outside.
Right.
Well, but they can.
Yeah, that would be, yeah, sorry, go ahead. Do you want to make a comment?
I think the other version of the same question is, can we take one of the deck boxes that has the uplink feature and put some of the switches inside or adjust it through the software to make it talk to a 9 that does not have the uplink feature?
Yes.
And we can do it in the field?
Yes.
Okay.
Yes.
So good.
Yes, as long as it's and as long as it's obviously with care, because you're going to open the deck unit, right? And as long as it's with care, there is a schematic how the non-uplink and the uplink the jumpers have to be. But yeah, if that's the case, just to make sure that you have the same version of the 9 and the 11, and you don't mix and match. But yes, the 11 can be modified, the 9 cannot. It's if you have an uplink version, which are not, again, like, I don't think it's very common, but there are some. As long as you have uplink or non-uplink, you have to modify the 11 to be the same.
Is that good for version 1 and 2 of the, is that what makes a difference on a?
I think it's version 2 right now. So I'm gonna ask Marshall. It's the V2. Yeah. Yeah, it's better if we have the serial number if there are any concerns, and yeah, it's better if we have the serial number to make sure if there are any concerns. But the V2 is definitely, and I want to make sure about the V1 as well. But yeah, check the thank you, of course. Yeah.
We upgraded ours, 2 sets, two sets with and one without. We were told if you use a mock nest, you cannot use the uplink version. If you're using is Lee in here? Elliot? No?
We use it. We have a version 2 with the uplink and we use it on our scripts, not now.
It does work?
Yeah.
We were told it wouldn't, but you're saying it does. So I was wondering if there's any other confirmation.
I can add a little bit.
Yes.
Uh,
Hi.
That's right. Hello. My name is Jessica. I work for Scripps with John Calderwood, who was mentioned a couple times earlier. But specifically for Scripps, and this is probably why we said that we couldn't use those. Our mockness specifically, we like to use the non-uplinks. So whenever we build out the mockness, we like to use the non-uplink. And then on top of that, we always try to make sure that the CTD and the mockness will have the same type of 9 in use. So we don't want to use the non-uplink and an uplink during the same cruise. That just requires going in between 2 different deck units, and or if you want to use the same deck unit, if you only have one, you'd have to open it each time and switch all the jumpers on the actual board. So we try to sail with 2, but especially during a mockness cruise, we just prefer to have the same type of CTD, so that way we can use one deck unit and just negate going inside of that deck unit constantly and having to switch around those jumpers.
Which is, can I ask you, like, switching the jumpers during the cruise, have you done it first? And is it something that is like a pain, or is it something easy? Would you recommend it?
Is that you need to open the deck unit upside down. So we install our deck units, or at least one deck unit, usually upside down on the ground.
Yeah.
So it's more accessible.
Yeah.
Just so it's easier to switch those jumpers around. And I mean, everyone will see tomorrow, perhaps. I work in the calibration lab specifically. We have a lot of deck units down there. Most of those also either live upside down or on their sides.
Okay.
Just because we're in there so often, switching them around. But again, we like to separate all our sensors because we have so many. So we don't keep them as 9/11 pairs. We separate them all, so the 9s go wherever they need to go, and then the 11s make their way around as well.
Okay. Yes, of course. Yeah.
So I was wondering, when you do these jumpers, do you do anything to protect for static electricity? Is that an issue at all?
It usually isn't an issue. Ideally, especially like at sea, you have this installed all around. You're not just being like, hey, could you hold this deck unit for me while I do these? But it's once you know where the jumpers are, which they used to be in these charts used to be in the manuals, and I don't think they are anymore. You need the older versions of the manuals in order to figure out which jumpers to switch.
Parenthesis here before you continue. I've noted that like there is a lot of confusion with the manuals and a lot of information missing from the new versions of the manuals, and yeah, it's I'm gonna mention that. Yeah.
Yeah, so yeah, there's also in the parentheses as well, there's the L's and there's the H's, older versions. There's different versions, obviously, of all these equipments and instruments. And so some of them have the H and the L versions, some of them have the number versions. So it's very
confusing. Yeah. Okay. Yeah. That's why I'm here. Yeah.
groups is doing, it makes a lot of sense. You got one deck box that does both things, and I know this whole thing of using the seabird with the Mach nest is something you've created, sort of in-house. I don't know why there's two ways, but this is not a seabird problem, it seems to me. It seems we have what we have, and we have to know how to use which ones we have. We can move on.
Okay, yeah. Okay, well, thanks. Yeah, thank you for the comments. Yeah, no, absolutely. Okay, when profiling, again, like a schematic diagram of how real time means that you see your data during the measurement is being made. So you can see, well, the CDD's profiling, and the 9 class does not have a memory or power, so it requires power supply from the 11, and yeah, and sorry, the data acquisition component measures the sensor's output, sends it back to the deck unit. The deck unit sends it to your computer. And in the middle of this system is a winch and a slip ring. That they're the mechanical means of getting the instrument down into the ocean. I know this is new information for all of you, but you're welcome. So you can also add, of course, a carousel at the end of all this system and get water samples during your ascent. And of course, if you don't have an application, if your application does not allow for real-time profiling, which it can be, I don't know, for some cases, the SBE 17 Plus must be used. It's an internally recording instrument. An on-contacting cable can be used to deploy the system. And the 17 Plus has 16 mega of memory and can also be programmed to make water sampling. It receives pressure information from the 9 and closes the bottle, and you just tell it where you want the bottle to be closed. Okay, so we talked a little bit about the pump and the whole plumbing system that ensures that everything is being measured in the same parcel of water, so you will avoid salinity spiking, you will avoid data artifacts. So the pump maintains a constant flow through the system. And while this is very important for data quality, it definitely complicates a little bit the configuration, right? You have extra tubing that you have to make sure that everything flows correctly. So we have to make sure prior to deployment that the tubing that connects the pump and the sensors must be arranged so that the air in the system can escape. The air that was in the system on the deck can escape quickly when it is submerged. Usually this is like for the first 10 meters, because as the instrument goes deeper, the bubbles start collapsing themselves. If bubbles collect in the pump, then the pump will be difficult it will not operate correctly. If bubbles get into the conductivity cell, I bet we all have seen that, and it's not good for the data. So it is very important, the plumbing system, the configuration to be appropriately connected. So I was talking earlier with Marcel a little bit, and we talked about vertical versus horizontal orientation. And as I was telling him that, well, vertical is when you don't have a rosette, you deploy the 9 on a case, and horizontal is when you deploy it with a rosette. But from what I understand, there are other applications users. Are there like vertical deployments on a rosette, for example? Any?
There are a number of rosettes because of their mix. Cannot fit a horizontally arranged to its cage or even without its cage. So they're very densely packed. EMEL is a user of some of those. And so you have to use the inverted tubing for pressure balance. It's shown here in the left picture with the degassing tube, the lifting detail that's there. Makes them on and purge, hence the time delay. Allows hopefully the water, assuming the tube is clear, the spout is open. Should be level once it's down 5 meters or more.
Okay, yeah. Yes, I was just going to say that an exhaust tube, in this case, runs from the pump outlet to almost the end of like the same level of the T and the C sensors, which ensures that as you profiling and you go, you do your downcast, then there is no pressure differential between the two, the inlet and the outlet. And the horizontal deployment, which is very classic for the SBE32. Where it's easier to plump. You don't have the downward, like this vertical configuration that will cause these differential pressures. Care must be taken to ensure that there are no loops in the plumping that would trap air. And yeah, the inlet and the outlet are the same height, so there is no sloshing effect in this case. It goes without saying that the DC DAC must be connected to work. So make sure before the deployment that the DC DAC is connected, and yeah, the disconnected DC DAC, the conductivity cell will not get any flow. You'll not have any good data. Salinity and density and the derived parameters will be bad. And of course, soaking instrument before starting profiling. That means that putting the instrument packets over the side and into water at a shallow depth, 10 meters. I guess there are many different approaches here for a few minutes. This has many benefits. The packets comes to water temperature, the conductivity cell waits with seawater, and very importantly, we flush out any bubbles in the system before start profiling. I'm guessing this is a common practice, right? This is okay. Okay, and how the 9 samples, the 9+ samples measures conductivity, temperature, and pressure at the same time, simultaneously. We recommend a profiling rate of 1 meter per second. That means for a 24 hertz frequency, we take a sample every 4.2 centimeters. Again, I heard today that there are applications that the descent rate is way higher than 1 meter per second. Okay, why not? And then we always recommend to sample at the maximum rate, and you can reduce your size of your data post-processing when you average your data. We talked already about the importance of DC DAC, because what happens is that we might match the response times of the two sensors. However, the physical distance of the sensors, and when we're talking about that high resolution, even this small physical distance can cause a small effect mismatch, let's say, of the conductivity and temperature measurement. So there is still some small alignment that needs to be done in the data. And this alignment, especially for the 911 system, not for other CBERT CDDs, not for the 19+, especially for the 911 system, this alignment takes place inside the DEC unit. And it has been very thoroughly studied in the past at CBERT, before obviously I joined CBERT. Calculations of flow rates, plumbing distances, sample rates, and the adjustment has been found to be 1.75 scan, not an integer, which translates, because it needs to be in seconds, translates into 0.073 seconds. So because the conductivity measurement is taken after the temperature measurement, the conductivity measurement is advanced automatically in the DEC unit by 0.073 seconds, creating an already very good alignment of the data. Now, further alignment might be necessary based on your specific application, your specific scientific goals, the environment, but to start with, the DEC unit already corrects for this physical distance of the sensors. And now something else that came into our attention recently when communicating with customers that the bottle closure events, when you take your water samples, you close your bottles during ascent. And do we stop when we take a water sample? We all stop. Okay, good. There were some cases that we heard that they didn't stop, and I know, I saw the face. I know, because they didn't have time, which to me is this is the main purpose why you're there. So this can cause a lot of data issues because you don't allow the water column, obviously, to like the turbulence to calm down, and so you don't really know what you're sampling, right? You're sampling something that it's below. You're sampling different parcels of water, and then you cannot compare really with your CDD data. So we just wanted to like highlight that it's very good to stop the packets for 5 minutes prior to the bottle closure. Less can yeah, yes, please. Yeah.
I think this is out of the scope of the technicians. I mean, I have heard anywhere from 0 to 5 minutes on this one, and it's a scientist's pick. We got nothing to do with this.
Yes.
And I do find it fascinating. You talk about stopping for 5 minutes, but the ship's rolling the whole time. I don't know what that's going to the water.
Fair.
And also 5 minutes per bottle on a 24 bottle cast on like, you have like 100 CTDs is a couple of days of lost sea time you could be using for other things. I mean, I just mean it is interesting. And I don't have to think about it because it's up to the scientists. Betty Marshall wants to say something.
Yeah.
I would sit in what you say, Robbie, but we have had experience with some fairly well-known scientists who insist on tripping on the fly. Say we'll deal with it. We have some scientists they very short stops. They, especially with some of the buoy packages that are very dense, like the PME host, basically it's a solid mass going in. We're able to flow inside the package. So there's certainly turbulence around. We don't know whether it's major or not, but the current and a few others just trip very quickly in order to get moving just for those reasons for time.
Yes.
And they've looked at this for years. They've made that decision. You can counsel your clients about that. Go on, just say, here are the people to talk to. It makes sense.
Yeah. No, no. Yes. Yes.
Sorry. All cruises. So 5 minutes is way too long. We don't want to lose that sea time. So what we do is a 45-second stop. If for some reason stopping is not possible, weather's picking up and we want to get the thing up, we will trip on the fly without slowing down. That's the key, is not to slow down. We know other groups will slow down and trip, but if you can't stop, what we do as Ghost Ship, US Ghost Ship, is trip on the fly without slowing down. That's the second best. That's too slow.
Taking less water samples is not something that you would consider, or to more strategic spots instead of 24, for example. Or... Okay. Yes. Okay. Fair.
45 seconds. They're not allowing us to stop at all, or they want to do it quicker, we would just trip at the full descent rate at the depth we want the sample at.
Okay. Okay. Thank you for that. Yes.
I might point out there are some circumstances where it reached a very consistent layer that's homogeneous for 100 meters or so. You can choose not to sample, except in that area on the uprace, this turbulence won't be as much of a factor. So you can get a couple of bottles, and it's very common for someone to work in the environment.
Okay. Thank you all for your comments, by the way. Okay, and I'm going to move on. Again, with the water samples, we want to make sure that the lanyards run straight from the trigger to the water sample. Don't have to stay there a lot. So, and for the last part of my presentation, I'm going to talk a little bit about the data processing data processing in general, as we're preparing for Fathom. I'm going to stick to the old software for now. Everything is going to be transferred to Fathom in a modern situation anyway. And I know that there are different protocols. I know that the GOSI protocol is slightly different than what CBERT recommends. CBERT recommends, of course, first you convert your data from your raw data, you create your CNV file. Alignment in the 9+, like we already mentioned, is not really necessary unless you see while you're plotting your data that there needs to be some further alignment. So filter is optional again. Align CDD, then cell thermal mass correction, loop edit optional, derive salinities you want to derive, parameters you want to derive. And at the end of all the sequence is, of course, bin averaging your already processed data. So cell thermal mass, I'm going to just mention here, there are two coefficients that we apply. This has been modeled and calculated for the 9. What cell thermal mass is that the conductivity cell retains some thermal mass. It has thermal mass. So as it goes from warmer to colder waters, the water that goes through the cell reads higher of correct in terms of conductivity because it's warmer than it really is because the cell has retained some heat, and vice versa for when you go from warm to cold. So to speed up this part a little bit, if this error remains there, the salinity that will be computed will be wrong, and it's going to look something like that. An example, for example, if you see the data shown in this plot has already been aligned, so there are no salinity spikes, but what we see is like some salinity hysteresis that and no temperature hysteresis. This feature that looks like that is actually caused by the effect of cell thermal mass. Loop edit is when the system, you can flag your data that have been you do not want to include in your final data plots and bin averages. It marks the data collected when the CTD loops through the water or decelerates sharply. So this is a schematic showing how ship heave can cause underwater packets to loop through water. Accelerations and decelerations caused by ship heave cause water entrained within packets to glow by sensors. And this is an example of some ship heave defects. I'm sure you've already seen these artifacts, these plots. And the left plot shows that each time the descent rate drops, the temperature and salinity are disturbed. The plot on the right is a zoom in basically of the top loop. And then bin average, and I know I have to, I'm almost okay. Okay, good. And the bin average part is where at the end of all the sequence, the processing sequence, we want to reduce our data size or the size of our data, and by statistically estimating data values at even intervals, you can bin average by pressure, by decibel, by depth, time, or by scan. You can bin average upcast, downcast, or both. The surface bin is treated separately, and there are two different methods, interpolated and non-interpolated. When non-interpolated, basically the two different protocols, depending on what you want to do, the non-interpolated version creates evenly spaced bins. However, the interpolation might not be an even number, so it might not be like 10, 20 meters. And I know that there are some databases that they want to bin average data on even bin size, like every 10 meters, every 20 meters, where in this case, the interpolation bin averaging must be used, which is basically a linear estimate of the variable at every bin at a specific pressure. Again, the surface bin is handled differently because the previous bin, based on the linear equation that uses the values of the previous bin, would be the air. So is assigned a beginning pressure or depth and an ending pressure or depth. And some general tips that bins with one sample obviously are not very statistically accurate. You may exclude scans marked as bad in previous processing steps, like in the loop edit. And surface bins should be 10 meters and above, because when they're very, very small, they're difficult to be processed. Finally, when we take water samples, we make our analysis, we want to make sure that what we will measure from the water is going to be correlated somehow to the CDD measurements during the profiling. So the 32 carousel uses a list of scan numbers created by CSAVE. This is the BL file. The BL file basically contains the number of the firing sequence, the bottle number, date and time, and a range of scans around the bottle closure event. This information is then used by data conversion to extract CDD data at time of water sampler closure into a .ROS file. And then you can extract this data and you can make a bottle summary, a table by bottle summary module, where you can have the average of each of these bottle closure event and the standard deviation for statistical reasons. So here is the steps in data processing. Again, very soon, I don't want to give a specific timeline, but soon is going to be a new software where the steps are going to be the same, but it's going to be, again, more modern and easy to use, user-friendly. So the source of your data, again, is the BL file. You create your detailed ROS file, and then you can also set how much time of the data will be of the bottle closure events you want to extract. So the scan range offset is how many seconds before the bottle closure begin extracting data, and the scan range duration is how many seconds total to extract data. You may copy a maximum of 1,440 scans per bottle closure. For a 24 hertz frequency, 4 seconds of data is 96 scans, just for reference. And finally, the BTL file that can use the ROS data file to create averages and standard deviations. I would like to ask if people use the BTL file, because it's one ongoing conversation we have at Seabird, if we want to modify this file, if it's used, or if we need more statistics on a data file like that, except for average and standard deviation. Yes, but oh, sorry. So, and is it, would you like more statistics in from the bottles, or is it enough?
Not personally.
Okay.
But as scientists might say, I haven't heard any complaints about scientists.
Okay, but the BTL file is used, we don't get rid of it. We want it. Okay, good. It's nice to have. Okay, good. Glad to hear that. Yeah, so, and here again, the bottle summary, you can select which variables you want to be averaged during the process from the bottle. They can be added, like parameters derived from the averages may be added to the BTL list here. And I will conclude with this slide, which is outside of the data processing world, and it's going to be, and I'm going to talk a little bit about care and cleaning of conductivity cells. There are different ways to clean the conductivity cell. Again, it's very important to keep it clean and keep the volume constant. So depending on what you want to do, what you want to achieve, there are different methods to clean the cell. So if the goal is to keep using it without sending it back to seabird and keep it as close as to the last calibration, the classic routine cleaning with the non-ionic surfactant, a little bit warmed up inside the tubing, soaking for maybe an hour, and then rinse thoroughly, and maybe add, then bleach solution, again, warm through the cell. This is the routine cleaning procedure that's recommended when we want just to clean the cell as often as possible. However, and this has to do also with like nines that are used next to moorings to see drift over time. If we want to see how much the instrument has drifted, the nine has drifted, or if we don't want to change what happened in time, gently rinse with DI water in between casts, and then return to seabird. So new coefficients can be calculated, including offset and slope, that can be used to calculate how much it drifted, the conductivity measurements drifted through time. Always very important, have it at the bottom with red letters. Do not put anything inside the conductivity cell ever. It's gonna damage the electrodes, it's gonna damage the cell, and it's gonna have a big impact on your conductivity measurements. And with that, I want to thank you all and take my questions.
Thank you very much. I have a question about the use of the value F0, which comes in the figure 4 conductivity calibration sheets. That's the default value of the frequency output in error. And we found that's a very good indicator when we're at sea, with the sensor having been cleaned and dry, as to whether there's been a shift.
Yes.
Something has been hit. If there's been something that goes through the cell or that sticks in there that's not cleaning out, that default frequency value can rise.
Yes, and if that's like if it's possible to see the zero frequency, the frequency at zero conductivity, and it's like a few tenths of hertz, it means that it doesn't read well and needs to be cleaned or returned to be recalibrated. Thank you, Marcel.
Carson, we use like a flow through fluorometer that I'd never seen before I got Kumbari. It's just a hole in the middle, water close to two tubes to it. What's the recommended way to clean that guy? Do you not want to shove anything down into the hole that goes to the middle of it?
This is one of the questions that I will tell you that I don't know the answer, but I'm very happy to get back to you with more information about the fluorometer, the cleaning procedure about the fluorometer. Yeah, if that's okay. Yes. You have
Yes, one. It's the one I have supports too. Being messed up. However, it also might be the one that is now obsolete.
Oh,
Probably is.
it's okay. Check the chat. Okay.
We also have a well star, and we also use like a pipe.
Okay, so I didn't say that's what we're doing.
See, that's what I'm saying, that I also learned so many things from today. Because you all use these instruments, way more than I do at Seabird. So it's very important.
I have a question, maybe this is to the group too. The pumps come on, you have them set up from the factory two ways, manually or through conductivity. we were experienced 2 trips this past year where we were near river runoff and our connectivity never got high enough to turn the pumps on. Is there an override, or we reached out to Seabird and I believe we were told there isn't, but does anybody know another way around that? Because like I said, ours are set for once we reach a certain connectivity.
Yeah,
Maybe in the future we have a change on that.
yeah, please go ahead, Mars. To my knowledge, there isn't, but yeah, you probably.
Seabird 9 defaults to observing hardware frequency counter with value of the C1 on J1 of the bottom JV1. So that frequency rises to 3,000. It will turn the pump's timer on 45 seconds, 50 seconds, depending upon the interval. There's no override to that. There is an option they can build, provides for telemetry downlink from the turn on or off pumps. So that's a hardware factory modification.
I got one. Okay.
Oh, yes. Hi.
Yes, hey, first to the pump issue, if you check the MacGyver award submissions, Grace actually had a pretty good one using funnels on the way down, throw water through the system. It's kind of neat. I don't know if it'll solve your thing, but definitely check that out. Check the MacGyver award submissions. Grace used it on the pellet. So in the flow-through system, we have a varied amount of instruments that have different flow rate ratings. And how critical is flow rate? Like the flow rate, recommended flow rate to the 45 is extremely low. We had a flow-through that also had a 21 in it, which was extremely high. So we were somewhere in the middle, but still pushing way too much water. Flow rate recommended, rate through the 45, and then some of the farmers don't have recommended flow rates at all.
Yeah.
Can you speak to how critical that is, or?
So the flow is very critical, obviously, for the conductivity. It's very critical for the oxygen, the 43. You're not referring to 43. Sorry?
Mostly the.
Yeah. Yeah. Yeah.
Water world here moved in on
Sorry.
the underwater world, and they're talking about equipment that's installed in the labs.
Okay.
Yeah.
Okay. Again, like it's other questions that I don't have an answer, but again, like that's why I'm here. Don't get me. I'm very happy to take questions that I don't know the answer and find the answer and get back to you. Yeah, or I mean. Okay. Yeah, if someone can give Johan, Johan is our director of science. Someone can give.
If you have any questions that we don't answer today, please reach out to us. I think from a response time perspective, I think optical sensors are not as critical because they sample pretty fast compared to other sensors. I think maybe what be my concern is that how well is it mixed? That flow TSG obviously have maybe a little bit less accuracy anyway in terms of the water you suck in, but variability that you encounter there. But so I think having a good set measurement, that you want to achieve in terms of flow rate is probably important. Yeah, better. Well, I have a microphone. I actually have a question for you all. As Marilyn said, we are trying to basically replace a PDA processing which has a bit of a dated interface, something more modern. And one of the big challenges is obviously the 911 has a lot of features, a lot of different combinations. So we thought this would be a great opportunity for you to give us feedback. It doesn't have to be right here in this forum, but at least in some form, reach out to Seabird in terms of what you like about the 911 system right now, its interface with the various parts of the software, and what we should consider going forward. So I think this is really important. For instance, I've seen maybe one feature that maybe useful is we talked alignment, to move additional validity spiking in data. Something like that could be offered almost automatically. The software suggests, hey, here's a better value for you that you should be using compared to this thing. Things like that. So think about what you like and what you don't like, what you'd like to see in the future, so we can consider that in our development.
If no one else has any other comments or questions?
Marshall from Boeing, I just would point out those are oftentimes dependent on clients' needs for adjustment of the flow rates of instrument string and precedence, what instruments where. The cross-sectional flow rate differences throughout the tubing are really complicated matters that has to be verified in practice, from my experience. So start with your client, see how important it is. You might even have a secondary water system. It's important.
Yeah, what Marshall said, that I'm like, I don't think we're the clients. We're not the scientists. No. Anyway, that's it. I guess that's my comment.
Once again, request.
Okay. Time break. So back here at 2:15 to talk tech stories, I believe. Okay. Enjoy your break. Whoa. Right. Jumping about that. Okay. Just give me. I can't. Yeah.
Did you send me, Sonia? Oh.
Afternoon, everybody. Hello. My name is Gabe Mathias. I'm the Science Operations Manager at University of Alaska Fairbanks on the RVTEC. And my talk today is Tech C Stories on Open Discussion. A little bit of background about me. I've only been on the Sikuliak for a year. I was in the tech pool for 4 years. I bounced around. Yeah, tech pool. I found myself in a lot of strange and new and different and sometimes uncomfortable situations. I was on the Endeavor for 4 years before that. Uh, uh, Rest in peace. I don't know. And what? Still floating. Yeah. Despite the hole. Sorry. And I was at the University of Georgia before that, not full time on the Savannah, just filling in every once in a while. No Savannah people. So I want to hear your stories today. I've only got like 4 slides. I'm hoping that we can open this up, have a good discussion. Think about teachable moments that you've enjoyed, learned from. I want to show the newer techs in the room that we're all human. The older techs, 10 years. Let me see who I got. Who's got more than 10 years? Yeah, I see you. Right on. So I'm looking at you. You guys got to start. I want to show that us cool kids, we make mistakes too. We're all human. We're happy to talk about it. Right, Matt? Happy to talk about it? Yeah, cool. And we're all going to learn together. This will help. I'm going to show a couple quick hard-earned lessons of my own. I'd love for the audience to as well. And if that's the whole story you have is, hey, I did this thing, it was broken, I fixed it, I learned it this way, that's great. And a little bit to see if any of these resonate, if I say a story and then everybody in the room says, yeah, I stepped on a nail on the back deck of the Endeavor too. Okay, so we need to clean up the nails. Like, is there something as a community that we all run into here? Some story that no, there's no, I'm sorry. I'll stop picking on the Endeavor. It's a great boat. Uh, and last but not least, this is a huge community of incredible people. We've got RVTEC, the listserv, and as you stand up and say, "Hey, I did this thing," and everybody sees you, and they're like, "Okay, so when that person asks a question on the listserv, I know them now. We're friends now. We solved the problem together now." Yeah, this is a community building exercise more than a specific talk on a specific subject. The official description was shared stories of things gone awry. Bring your difficult situation and how it was handled. This will be a supportive and learning environment, except for when I make fun of the Endeavor. Oh, which button do I press? So the first one, this is an early lesson for me in my career. I was at the University of Georgia at the Skidaway campus. I was handed a bunch of these bottom frames with Seabird 19s on the bottom there, Seabird 19 pluses, I think. The long white cylinder, and they're full of batteries. And my boss said, "Here you go. Change all the batteries in these." And there was like a stack of them. I forget. It was like a dozen. And so I'm going through, I'm opening them up, pouring them out, pulling the batteries out, putting new batteries in, screwing them back shut. Yeah, I'll figure out how to program these later. I get to one and I go to unscrew it. Can't. And again. So I put the bottle in a vise. I get a wrench. Nothing. Man. So I get a bigger wrench. It moves a little bit. All right. So I get the BFW. And finally it's moving, slowly but surely. And right as I get to the last thread, pow, the cap goes flying across the room. I dropped the wrench. This is loud noise. It had been on the bottom of the ocean. It had flooded and it was pressurized. And so it had, whatever, 100 meters is 10 atmospheres is 150 psi inside. I'm making up numbers here, but give you the idea, right? And so at 150 psi on a 4-inch cap, that's 600 pounds pushing on the back of that. Of course, it went across the room. So flooded means pressurized. I learned the hard way that I should open things carefully that have been on the bottom of the ocean. And I've carried this with me. It's a very, it's a great teachable moment. Another story is secondary containment. I was on a ship and the scientists we've all seen these 5-gallon carboys right on the left here. And I had a group bring a whole bunch of these, but one of them happened to be full of high test science ethanol. And they propped it up on the counter and they had the spigot hanging off the side and they come over and they do their thing and they, whatever, dump it out in the sink or I don't remember. But it was the beginning of the cruise and they set it up and they were a repeat customer and they, I was pretty new and yeah, this is how we do it. Okay, cool. And it was in the wet lab with a door. And so they set up, we got off the dock. I don't know that everybody actually got seasick, but I'm gonna tell the story that everybody got seasick and nobody checked on it until the next morning. And somebody opened the door, and overnight that little spigot on there, where it's threaded onto the bottle, had just drip, drip, drip all night long and dumped 5 gallons of highly flammable ethanol on the wet lab floor that was sloshing around in there. And so you open the door, and it's like you probably could have gotten drunk just breathing in the air, but it was also a terrifying and very flammable environment, right? This is high test ethanol. Luckily, it was the wet lab, and so there's a little bit on the floor sloshing around, but we just ran the hose in there and rinsed it all down the drains, problem solved. Could have been a really bad scenario. Could have been terrifying. The lesson learned here is have secondary containment. If we had just put those in a little tub, it's simple. Just put them in a little tub, keep it contained right there. Wouldn't be distributed all over the room, making for an exciting environment. So that's not actually the chief scientist. For those of you who don't know, that's not a bad chief scientist, but bad bunny. So this is an interesting story. I put this in here to change the flavor. So this isn't, as marine techs, we deal with a lot of instrumentation. We deal with a lot of exciting scenarios out on deck, but we also deal with some sometimes challenging social environments. And so I was a fill-in tech on this ship. I had never sailed on this ship before, and the chief scientist was not a good chief scientist. And it ended up making 3 of the scientists cry. Like, this is a professional environment. We're here to work and learn. Like, that's not acceptable. And so I'm a brand new guy, and I saw one of these occurrences happen. And I'm just like, what do I do? And that scientist came to me and said, hey, this isn't cool. I need to talk to somebody. And I think at the end of the day, if you're at your institution and you're what's it called? A designated or say it again. Mandatory reporter. Yeah. Yeah. So you have to do that. Me being a hired gun, it was gray, but I also wanted to put in my 2 cents. And I blindly reached out to the program boss above the chief side. This is part of a larger program. And said hey, do I talk to you about this? I've got some comments, and it all worked out in the end. But the moral of the story is, read the signs in the back of the bathroom door that says Title IX reporting office. Here's who to talk to. And for those that want to hear the end of the story, this person has not sailed since that I know of. And I did kind of snoop around a little bit before this conference. And yeah, sometimes it's not as clear as the movies, right? It's not like this chief scientist didn't do anything illegal. Like it wasn't illegal, but it was disruptive. It was painful to watch. It's tough. And again, we're professionals. This is a professional environment. You shouldn't have to deal with this. And yeah. So with that, I'm sorry I kind of ended on a little bit of a downer. I should have started with the wrench exploding, whatever. I want to open up to the floor. I want to real quickly, you'll notice I didn't use names. We're not here to trash people. We're here to learn from each other and not to judge each other. We're all human. Anybody want to share something exciting that happened to them recently? Nothing. Who's lit stuff on fire because the ethanol got out?
So I got, this one's more of a technical issue, not necessarily a personnel or conflict of interest. But, so I had a source, I used to sail on the ocean. And, we had one of our cameras, we had like a old CCTV camera system, but we swapped over to IP, too long before the story happened. And there was a little bit of a leak in the winch room, and it was leaking right over like the power supply for this camera, and it just ended up leaking onto this little switch and everything, and ended up burning. Now we can't see in the winch room and everything. So and we're still transiting. So we were headed from Oregon down to California, and I ended up having to like take out the switch and everything. I put a new switch in, and it started working again. I was like, oh great, I fixed the problem. The camera's working again. We can see like our winch issues and everything. I was like, cool, it's great. I thought unrelated, later in that day, maybe tomorrow, like internet stopped kind of working for some of the scientists. Not all of them, but some of them were like, hey, I can't, get traffic off the ship. Well, during that time, we had like high speed net come down, and they did some things. So I was like, oh, those dang high speed, like they're great. My issue, not their issue. But like, I was trying to troubleshoot, and I was just like, what was going on? They're like, we like swapped out a buck or something. Like, there's no way that this is causing the issue. And I was like, but like this was the only thing I had changed with satellite things, and people, and it kept on cropping up more and more. And this was going on for like 3 or 4 days of like people were getting internet off the ship. And it was just really weird because I was having them look up what their actual IP address was on their devices. And it kept on like being super weird. And it wasn't actually the IP address that we had for like the systems and everything to get off the ship. So ended up, I think Croy Carlin, who now works for Hui, he helped me troubleshoot this problem. He was like, hey, that switch that you used to, swap out for the camera, that's like the power source and the switch. Like, was it managed or unmanaged? I was like, I don't know. Oh, come to find out, I ended up putting this unmanaged or this switch that basically was creating its own network on the ship and taking all of these scientists' IP address and keeping them from going off the boat. Meanwhile, I had to like hide from the scientists and the crew like during every meal because they're like, when is the internet going to be working again? I'm like, I have no idea. I don't know what's going on. I'm a new tech. And yeah, so always make sure that if you're putting a new switch into a system, that it's not trying to make its own IP network because it'll cause many issues for you. Thanks.
Awesome.
Fun fact on that one, printers are evil and will also try and make their own money.
Yeah.
One of the big ones that I had for C story is structural paint and why you need inspection gear. On a previous ship I was on, we went to go and do a pull test for a 681 wire. So we're setting all the stuff up. We've got it going, got hooked up the A-frame, and we're pulling it off a cleat. We back up, I start pulling it to tension, and the cleat snaps in half and flings itself 2 directions across the deck, barely missing someone. It turned out when we inspected it that the crew members in charge of maintaining it had just continued to paint it yellow. You could see a good thickness of yellow paint over rust. Obviously, this is one of those things where even if it's not your gear as a marine technician, also inspect it. We were using it, we were hoping the deck was maintaining it, but we should have checked it closer because we were using it and we were putting it under tensions that could have easily been dangerous. So there's always that in between of, we're always in between deck and marine techs, what gear we use, really just comes down to just check it. It'll just save you time and save you the effort, find out later. The other one that I have is the sort of in between of deck personalities and science personalities. And also my own mistakes as a beginning technician working on the deck is we were recovering a mooring. It was just a small, shallow drifter mooring. And I had checked with the scientists and they're like, oh yeah, it's the normal thing that we have. So it'll be this and then this meters and this meters and we'll pick it up and then there'll be the weight at the end. It ended up being incorrect because things had changed and not all the communication had happened. And I also was dealing with crew members that were very experienced, and so they had their own way of running things. So at being in charge of the deck, I was dealing with trying to make sure that they don't start bringing the A-frame in. They actually keep the winch coming up at the correct speed, not, just hauling it up as fast as possible. And what ended up happening is I'm cleaning up the deck. I see a line on the ground. I grab the line. I turn around, toss it out of the way of tripping. I hear a thunk. I turn around. The weight had hit the hull of the ship, swung out, and then swung directly towards me. I managed to just barely avoid it. And we got everything on deck. But it was a situation that, again, there were lots of different components and communication errors and even my own error. I should have just picked the line to the side. I should have dealt with that earlier instead of, that possibility, but I didn't know that the anchor was going to come up that soon. I thought I still had a couple hundred meters. I should have told the crew members to put the A-frame back out and to stop A-framing in. I should have told them again to slow down, even though, that had been communicated multiple times. And it ended up with a debrief session with the scientists that was on deck, as well as the crew members of how we need to work together to avoid similar situations. But it was just a learning experience of all it takes is little things. Like I just moved a line and turned away from the operations. They were going at, excessive speeds and also bringing it in without being told. I didn't look over the actual mooring plan, and the scientists also, was not aware of the change that had happened in the actual mooring that occurred. So just small things to check over. Like everything turned out in the end, scientists were happy, the ship was perfectly fine, but it could have turned into a big thing. And I think it's just things that especially newer technicians can look at and be like, okay, when I'm doing mooring stuff, I look over the mooring diagram. If the scientists don't have one, I'll ask for it and have them, even if it's just a doodle, I need to know what the distance is, what I should expect them to stop. Are there sensors on the line that I need to pick up? If there's issues with crew members of not listening to you because they might view you as, not as experienced as them, take it up the chain. If there's a bosun on board, and even though you're running offers, talk to the bosun, talk to the mate, talk to the chief mate. Start having those communications because everyone needs to be on the same page, or something that is very simple can turn dangerous very quickly. So,
Thanks, Sonia. I want to hear Pablo. What do you got?
This is just an IT story. Second time I was sailing on the NBP, normally we run two IT guys, 12 on, 12 off, opposite ships. We're coming back to the Drake. So we're rotating back to the same ship. And Sean and I think Sean had just come off his thing. We were overlapping, functionally middle of the night for us, and phone in the bunkering room. Phone rings again. Bang on the door. Sean, Pablo, we need somebody. Okay, Sean is out like a light. I mean, he's so okay. I get up and get down the corridor and smoke. Damn it.
Oh.
And you go downstairs. I pass a bunch of the crew in fire gear, and basically the UPS is uninterruptible power supply. Big, massive bank of them is smoking, and they want to hit it with all of their firefighting stuff, but they want to make sure that we have all of the computer stuff turned off, nicely before shutting power down. It's like ship catches fire, hard reboot on the systems. I go ahead and I try, probably takes me 20 minutes to get everything shut down because I'm groggy. We get it shut down. They douse the UPSs. Problem goes away. They get everything back up on the generators. I bring the computers back up. They pop the UPSs back online. We get this power spike that takes out everything. Destroys our DNS, destroys our servers. I think I don't know what I think my first lesson was, in that case, they should just shut their machines off. You're just overpower. Computers survive being powered off. Hard power off. That's not a big issue. Ship catching fire, that's more of an issue. I guess the second thing is when you bring things back up afterwards, take your time to think it all the way through. It's not just like emergency is passed, let's fire it back up. Sort of like your thing of, okay, we've got this thing back on the surface. Problem's over.
So Gabe said something more looking for something recent, but I think back immediately to crab fishing down in the Antarctic, deep water, haven't worked those depths before with pots. So we were coming up with some creative ideas as to how to recover this piece in here. The lesson learned is we broke a bunch of things, but the positive side of what we did is we thought everything through, and people were standing where they're supposed to, away from dangerous things as you're part of. We parted a block, we parted a line, because we knew that these scenarios come up. We didn't know some of the tensions that we might have been experiencing. Those crabs had traversed through a couple days of rough weather, so we're like, oh, maybe everything's snarled and bound up on the bottom. There's a lot of unknowns. So in that scenario, just the lessons learned was we needed to make sure we stepped through all of our safety procedures. And when one of the blocks decided to launch 200 yards off the stern, no big deal. Everyone was out of the way. We got a really cool road in here. And then a kind of shining thing for Dyneema is it dies when it parts. It doesn't snap back. So everything was Dyneema line. And when the line parted, it just went slack. And it was great. And we went, oh, there goes that piece of gear. Where it led to benefits is that taught us a lot for the next season when they came back looking for the same goal and objective. Beefed up the gear, beefed up the rigging, changed a little bit of the objective, the soak times, the amount of traps on the trawl line for that project. And their second season was super successful. So first season, not so successful, lots of broken pieces. Second season, really successful. And that because of the steps and processes that we talked through. Both in planning and in operations. So a lot of the conversations happen
cruise, but then we had more conversations and more planning and safety during the cruise as we were developing what was happening.
Thanks, Matt.
Mine's not exactly a story. I'm just curious to kind of hear from the community how their organizations deal with this. Worked for a couple of different places, and coming from the tall ship world where our mission was like education and leadership, we spent a lot of time talking about our mistakes and walking through error change from like a bridge resource management side of things. And I think they really, really excelled in that. And I find that it's not something that is poorly done in this industry, but I find it harder to have those conversations in the workplace. And that for some people, there's more like fragility and talking about mistakes we made and debriefing them as a group. I'm curious that other organizations, you guys have modes of not just incident reporting, but if you guys have like a system for debriefing and talking about in a constructive way when you make mistakes and learn from each other.
And do you use it?
And
So USAP actually did a number of processes around that, because we're kind of not fully, that kind of like outside, like working alongside. We would do a lessons learned for our marine orientation to bring everybody in and go through an hour worth of slides. And one of the constant feedback from that was we didn't spend enough time. People wanted to talk through these more, and they were things from IT issues to everything I broke on the deck at any given moment, to medical staffs too. We also would have our medevacs throughout the season. It's like, okay, how could these be done better? Not providing patient data, but what can we do as a community and as shipmates? Because everyone knows in a medevac scenario, you've got shipmates involved that might not be directly the medical team, but if you're carrying somebody, you're going to need to get approval on how do you do a litter carry through your ship. One of the ones that we learned on the MVP, you can't litter carry somebody from the kilo deck straight into the hospital. You have to go around the bow and around the outside because we bought it and litter. It was too big to make one of the turns. So a lot of conversations like that. So I would encourage organizations to have at least an annual lessons learned discussion.
what was involved? Like
We ran with part of our annual marine orientation. So all of the marine techs, IT, ET techs would all go to Denver for a week on the day session. Like we're going to talk about this, everything that turned out to be an incident or an error report. What's also important is you should not only mark the things that like broke or went wrong or caught fire, but your near misses too can help to categorize where you almost had an issue and how you can not prevent that in the future. So encouraging a culture that will report like, hey, we changed that shackle out because it was getting a little weak and we didn't want something to drop, fall, or damage something. But why did that shackle get weak? Like somebody replaced that shackle last year. Oh, it turned out it's the wrong size and it's shaped its way faster through that. Things like that.
So I was also in the USAP, and I think to your point, when I was there a couple of years in, they brought in some field staff who were former experiential education instructors, and they were bringing skill sets and processes that I felt were much more productive and really made big changes in sort of like safety protocol. And I think it points to sometimes we just need to bring in different concepts and ideas from different, sort of industries.
So on Bonnie's question, everybody's got some sort of reporting schema. and hopefully some sort of near miss dialogue in your team. But who here has ever recorded a near miss? 4, 5, 6, 7, 8, 9. Who here doesn't know where to file a near miss report? 3, 4, 5, 6, 7. All right. So, wherever you are, maybe that's a great lesson from this discussion is go home, ask your boss about near miss paperwork. Hopefully you scare the daylights out of them or her, and it helps you get that conversation started for when you have Bad Bunny come on board and you know what to do.
Hi. Yeah, I'm John Swallow. I chair the safety committee. Decided to come here because I figured some of the issues that tech would have are safety related. A lot of the larger organizations that have a safety management system, which must have a near miss reporting system, and they also have risk assessment, all that kind of stuff in there. We're also trying as a committee is to highlight more the near misses and things. So we have the safety meeting every year. I think a lot of the near misses stuff don't get to the level of the superintendents, but I encourage you to kind of pass it up to your in command so they can get there. I'm also open to ideas to kind of communicate near misses more throughout the fleet because as you guys all know, it's a learning experience for everybody, and it's something on one ship maybe somebody didn't think of it. It's really, really helpful. So open to ideas, but it is a focus that the safety committee is trying to take this year is to try to get this stuff elevated and back out.
Great to have you, John. Real quick, one thing I would pass to you, and I think a lot of people here would agree, is that SMS is a bridge product. The mates and the captain and some of the engineering really, that's their baby. And a lot of times on a couple of ships I've been on, it really feels like there's a disconnect between the bridge and the mate or the technicians in regards to tending and loving the SMS because it's they're focused on coasty stuff and we're focused on science stuff and that doesn't always get together.
It's a big heavy lift for documentation, so a lot of folks documentation getting the inspections done, but is really getting the deck plates. That's kind of my concern. I'm open to hear what anybody else feels about that. Is everybody having, feel like they're having adequate, like before you put something over the side, kind of a walkthrough, here's their plan? Are you taking the time to do that or is it kind of rushed? I know I've seen on ships that I've been on in the past, you have like someone who's been there 30 years, they think they know it all, and they're gonna try to do it their way, and you get that kind of conflict, and that's kind of been mentioned earlier. It's a delicate balance. But as a technician anybody who's working on the deck, you have the right to feel like you know what you're supposed to be doing in an operation. So the master, anybody should have your back if you have a question or say, hey, are we really gonna do it this way or not? I mean, you have the right to be heard.
Oh, we got everybody interested now. A lot of response. I think Eric's had his hand up for like half an hour.
All three of us we do EBS internal audits, and that's what we do the accident review and the follow up. But I think my takeaway from this is that the technician, it's generally leadership only at those meetings, right? And the techs are the leaders, and they should be invited to those meetings. So that's something that I'll bring up on the way back. And also, kind of like thinking about Kristen's story, like getting more equipment and lost time type of things reported as incident reports, so that the tech can do a better job of filing those reports. And ABS loves to do that. They like lots of reporting because it shows that you're following your processes.
This one kind of dovetails to what Matt was talking about, and maybe it's just like you need a couple tiers of ways to do this. But one of the things that is required on the USAT side is annual review and approval of your SOPs. And it's a pain, you have to go through all of them. And sometimes you have an awesome senior tech and you can touch them with some of that. Thanks, Matt. But you had to go over all of that. And at the end of it was, we changed things, lessons learned at the end. So it's kind of a running log of, it wasn't track changes like this is how we used to do it, but it's your updated procedure. It's followed by lessons learned and things that, we found over the years that were a problem. And so, just reviewing your SOPs and making sure they're up to date is awesome as well.
Yeah, I just had something to kind of add to your guys' conversation, especially when it comes to like near misses and reporting that. The current situation that we have, for most of the vessels is after the cruise is done, the technician makes a report, the captain makes a report, and the chief scientist makes a report on, how well the cruise went. But I'm almost thinking more of like just like these safety things and near misses, whether it was like an actual safety thing or maybe some sort of bad chief scientist kind of situation. If that could be kind of reported back to the safety committee, if they had like some easy way to fill out like a report, and that way, all that data gets to go somewhere, and then maybe some group reviews it and says, hey, and it could be anonymous too, but like all these ships are having issues with X or Y or Z. And the reason why I'm thinking about this is a number of years ago, there was a lot of different vessels with different situations that all lost their CTE rosettes, right? And it was kind of one of those weird things that at one point Jim Holland was just like, stop losing CTEs, and also why are we losing CTEs? And so there was actually a working group for the water systems because this has happened on various vessels. Some of them, they did like a deep dive on this reporting. And some of it was like human error versus equipment error, but it wasn't until like after I think like 5 or 6 of them, popped off the end of a wire before this conversation had. So I'm just wondering if like there could be an easier way of like reporting and then getting that information and then kind of talking about it as a community, sort of like this, that we could address those issues, both personnel wise and also safety.
We're all going to come to the safety committee meeting next, whenever it is.
Before the next summit, sorry to interrupt, can I just send a reminder to the folks upstairs? If you guys want to make a comment, please use the microphone. There's one right there at the center, just so in case anybody wasn't aware of that. Thank you.
So I think one of the other, Ross touched on it a little bit with the SOPs. All of our SOPs, JHAs throughout all the USAT are constantly reviewed, growing documents. But one of the other things that I feel we did really well in the last 5 to 10 years was an encouragement of our new coming techs to put their input into it, because that avoids some of the that built-in knowledge, that 30 years of experience. It's like, okay, the 30-year experience guy had put his knowledge into here, and now we're having a new guy read over it and constantly editing, changing that, so it makes it so it's no longer in 30-year experience brain, it's on that piece of paper and fully graspable for anyone new. Document specifically thinking of is our 322 termination document. I can hand it to anyone in this room, whether they terminated 322 or not, feel fairly confident that they can do a mechanical termination with maybe 1 or 2 questions.
Have you talked to the wiki group yet?
And yeah, I guess the thing I want, there's a lot of management. There's the like kind of like documentation and official reporting side of this that gets back to the safety committee, but that doesn't come full circle back to the people who are working operationally day to day. That we can't learn from it. And, finding a way to have this be an active conversation. I want to talk about this stuff in real time. Because otherwise, it's great to have all that data together. It's the shared mental model of safety in the fleet, super important, but we can't learn from it unless there is some transparency there.
What about adding sessions to next year's RVTEC? So similar, oh, go ahead, Mike.
Everybody online is wondering what's happening.
No. Having participated in those, USAP annual meetings, it was super valuable to have that day of like, hey, let's all talk about what went wrong in the past year. Maybe we could add a session to architects, like, come with your stories of what didn't work over the last year with safety was. Yeah, like, I guess we didn't come.
This wasn't the goal. Yeah.
I'm more that's like, let's come with like, what did your ship have? Or if you don't want to share that, just tell a few actual near miss or accident stories.
I just want to also make a comment. I feel like, at least on some levels, there's some resistance to allow us to say, or to air out some of our dirty laundry or things that were mistakes. Things because it makes that institution look bad. Something so you also needs that culture of sharing and acceptability.
And that can be tough with some salty old sailors. I wonder if we could, funnel these through the safety committee and have the safety committee digest them and give us a RVTech specific chat next year. Put that on in your mind.
Yeah. Having a specific session would be good where like people bring the topic so I can, because right now there's a form, a UNOS form that all the superintendents fill out everywhere about the medical incident. Any medical incident on the ship is reported quarterly. But there is not an official like form that you have for your misses. That might be overkill. Maybe just having like kind of like a session like this. You can have a session like this where people are encouraged to bring like one slide on an incident. That way we have some documentation. Take that back and be a subset. Allow the Texans here on the safety committee too. We can go over it at the safety meeting as well. But I'm more interested in like when I was in the Navy and at NOAA, there was different things NOAA had something called the safety seagull. So then, if somebody was paid or whatever, they had enough staff work to be able to put together these different near miss incidents, and it got put into a PDF or something that's sent back out to the fleet, and everybody reads, like just a couple of paragraphs, like, oh yeah, that was dumb, but I could have done that myself, stuff like that.
Yeah,
that's kind of what I'm thinking somehow, but I don't. I can take some ideas, but to me, that's how you get the stuff back out to the deck plates is where it really needs to be, right?
we have a thing that comes and goes, but we call it What Went Wrong Wednesday, and where we kind of do the same thing. We bring up a system and talk about it, and it's become a little more educational on the system as a whole. But the original idea was just that, to talk about a failure, destruction of something, and how they had solved it. So I think there's momentum there. I think that's a great idea.
The best thing place. Then at the end of the year, you take one or two examples, and then that would be presented to the entire group. But it really needs to be done at the operational unit level. And if there's a near miss, there should be, there's near miss reporting requirements in the SMS, but there should be like a debrief. And hopefully the culture is open to that when you kind of learn about that from each other and accept it and just learn from it on.
So this was news to me that near misses don't go to the safety committee. They just stay within the organization. Is that correct?
Yes. As part of the safety committee, I've never seen like a report on one unless a superintendent volunteered to say we had a fire on the ship. And I'm going to tell you about it as you guys. But there's no formal way to do it. It's more like voluntary.
Tara.
I really like the idea of this topic as a session, but I used to work at the University of Hawaii for a really long time, and I had several near misses, several cruises. A lot of times, I was a chief scientist on board as well. So not only was I deploying stuff, I was also part of the near miss. So, or with my team member who had the near miss. And that really just goes to the University of Hawaii. It never went operational to the ship. It was something I had to deal with UHHR. And maybe that's where some of this disconnect is, because we don't really talk about it in our post-cruise meeting, really, or like take it up to that level. And for a while, MFP, I mean, we didn't have MFP then, but we did have to do the post-cruise assessments. And you don't want to air your dirty laundry in those. So I think there has to be a shift where we can kind of feel comfortable saying this happened without it looking bad or saying we're not going to fund you anymore. I think there's a little bit of fear there. That's all.
I wonder how we could anonymize this to share it back with the community. You know, still do your reporting, do your near miss, and then some magic central group. I'm not looking at you, John, at all, I promise. You know, choose through it and then shares back with the community what's happened on the ships over the last year without saying names or ships or
Yeah, I mean, I don't know how many people have been on a ship where someone lost a finger. I know I have, but I've never heard about it in any report anywhere. So where did, yeah, I think it.
I guess. Yeah, I'll make sure this is a topic at the safety meeting in May, but I could also have, reach out to the superintendents and tell them, bring a near miss topic to the meeting.
yeah.
And they would have to reach out to each of you guys on your vessels, and then that in itself could help stimulate conversation about what, and at least kind of help put a little spark to the culture, reinforce it, I guess. Because I know States, it's got a really good safety culture in general. So, I mean, does that sound?
Yeah.
Like an idea?
That sounds awesome. I think that sounds great. Any other stories? What you got, Russ? Wait.
Okay, so this is an interesting one because on the USAP vessels, we move containers. We're moving them to the stations, etc. And usually originally we would use a spreader bar with, positive blocking hooks and cables on each corner. And you would hop up on top of the mill van, they bring the spreader bar, you go up to the edge, make all your connections, hop off, they do the lift. Safety department came down, no more people on top of containers. And then, well, first it was like they need fall protection. I'm like, wow, something about them. So if you're on two containers, you can fall protect. On one container, so they came in and like, okay, well, you gotta use a ladder, gotta be coming from the deck, someone's gotta be holding the ladder, and you gotta use screw pin shackles with a cocker. Okay, so now you got to tack up on a ladder. There's a giant shackle though, with this giant pin. So one hand for the shackle, one hand for the ladder, one hand for the pin, one hand for the. Yeah, it's starting to not work. So we were having problems. We tried to get an exemption. Like, well, if the techs are on their knees, can they like make that connection? And they're like, what are you gonna do? Well, in the end, we were. Basically, they told the techs, like, you get on a container, you lose your job, So now you're like, okay, I'm gonna load code. And ultimately, it led to me going back and finding some money from NSF and then purchasing auto lockers and changed to, people stay on the ground the whole time now, and we just changed to a different system. But it did take years, right? It took an incident, and then it took you know, a bunch of telling that didn't work, and then it took, you know, thinking outside the box to get a solution.
Those are wicked cool, by the way. I saw those when I was down there. It's like, oh, I need one of those. We got just a few 7 minutes left. I'll wind it down. Big thanks to everybody. Unal's office. Maria, thank you. Thanks everybody for sharing stories. Appreciate you maybe getting a little out of your comfort zone and speaking up about things that were sometimes sporty. Uh, I think some great stuff came from this. I'm excited to bother you more afterwards. I'm sorry I picked on you a bunch. And I hope I didn't scare any new techs in here. As you know, and last but not least, thanks Sonia. This was all her idea. Thanks everybody. Oh, and everybody on here is on the RVTEC listserv. So if you can air your dirty laundry in here, you can do it on the listserv. Ask questions. We're here to help.
Do anything like that?
I'm gonna get instructions. Are you in charge of this?
So I'm
Okay, you're the next speaker.
You're in charge. Well, thank you.
Is it all on here? Can we confirm
Yeah,
that?
let's do that.
Can I edit anything?
In here, yes, you can. I did, let's see. Let's make, oh. Wait a minute. Sorry about that.
Something biofouling, Hank Loeb.
Yeah, I know you're in here, and for some reason, I'm suddenly having a moment of,
Well, you have a lot to do this week. We don't have anything.
let's see. Military. That's strange. Okay, hold on a second. Oh, this is what I want. Like, what did I do with this? Here we go. Okay, so here we are. This is what I found.
How many do you have? One or two?
Just one.
Okay.
Is there a second?
It should be.
If you
I can't
want-
remember. I switched them around.
If you want to update anything, I believe you can do it here. Is
Okay,
this-
I'm just
this
gonna
is the
change-
PowerPoint mode.
Yeah.
You're welcome to drive if you'd like.
Okay.
And then when you're ready, though, I'm gonna just.
Hang on here.
Do you need- do you-
Let me see. I just want to. This. I'm gonna update this.
And then when you're done with that, I'll just make sure it's being
Backspace.
shared in the Zoom.
Fine. I'm done.
Okay, so that was just a little typo.
Yeah.
Okay,
I've updated my report.
okay, no problem.
2022 to 2024.
Meeting. Okay, so I'm gonna go back over here. I'm going to share. So now we're in the Zoom meetings. So right now it's just me. You can see participants
Okay.
down here, just me. If these numbers increase, they might put some questions in the chat, and you would see, like, if you hover your mouse over it. But I can help you with that.
Okay, that'd be good.
To open the
Yeah.
questions, if that's what
Okay.
can come in just very quickly, just, squeeze.
Okay, that would be
Yeah.
great.
Right. And then, and then we are going to just go over here.
slideshow's been funky.
Okay, and how do I advance this computer?
You can press enter space, you know,
If I'm-
like this backspace. Enter to advance, backspace to go back. Also, these arrows will work.
Oh, really?
Yeah,
Okay.
forward, back, that might be easier. You
That's
can also
easier.
mess with this part here.
Okay.
But this mouse has been acting a little funny. I'm gonna go
Okay.
get a tissue because it looks like there's a little spill here. Let me take care of that.
Okay.
Maybe a little coffee spill or something. All right. Did you have any questions?
No, I think I'm being.
Okay. Let me.
Alright, well, sample I made up. Oh, cool. Yeah.
One slide.
When I was suggesting that. Still like I don't know, very much. I had to do myself landscape for when I got my own. And trying people out of the way, right? So. Funny, sometimes just like instantly going to brain kicks in. But sometimes it can. At least I'm just making you take the crap of this. Yeah, yeah. How they she's a husband conversion. Yeah. I can do what I do at this point, you know. Yeah, why change down? Man.
Clean this up a little bit.
And where are you based out of?
Well, I work for UNOS, which is headquartered in Seattle, right in
Yeah.
Washington, but I actually live in
Oh, you do? Okay, gotcha. Nice.
Sorry, I didn't introduce myself.
Nico.
Maria.
So Nico works for the Ocean Innovations Company. So there are reps here. So Nico's going to introduce me and then take over.
Yeah, give me a secret sales pitch. Yeah.
Okay,
I'd say
you're in the right place. Yeah, it's no longer secret.
Where in Monterey do you live?
Right in the city of Monterey, right? Almost very like within walking distance to downtown.
Oh, beautiful.
Yeah, it's like I really love it. It's
What a
wonderful.
great place to live.
It is. It's marvelous. And it's, you know, sometimes it gets a little boring because it's really just a big touristy town.
Yeah.
A lot of retire. You know, there aren't a lot like really like cool events. Like my husband and I love to go to concerts and stores. Yeah. You know, like really big music stores and things like that. And you have to go to like San Francisco or San Jose.
Yeah.
You know, Monterey just
Far away though.
exactly.
Yeah.
But
It's nice to be in the quiet.
Yeah. It's lovely, you know, it's nice to be on the coast. It doesn't get
Yeah.
which we loved.
Yeah, I actually got married last year in the hills right behind Watsonville.
Okay,
So I did my a little like a mini honeymooning in Monterey.
so that's
Like Corlitos area?
yeah,
Yeah.
that's lovely.
Yeah.
Sometimes I'll take that drive from 101, it's like 150 something to 152, and go over the hills and then you end up in Watsonville on the other side.
Beautiful.
And it's lovely. Yeah, I love that area. Oh, so where did you, was it a venue on the hills or?
Yeah, I was up in the Redwoods. I've got a lot of family up there, and then my wife's family is from like Santa Cruz area or Sacramento area. So it's a nice kind of meet in the middle. So we're down here though, all my family. So yeah, yeah. So I'm born and raised down here. But I'll eventually make the move up there. I think that's kind of the move.
Settle.
Eventually. But who knows? I'm getting priced out of San Diego.
It's all getting, honestly, my husband and I didn't think we would ever by
Yeah.
20. So we have to relocate because we have that big real estate.
Yeah, that big dip. Yeah, that's great.
Actually benefit from that,
I'm glad some
we were in a position, I know. Found this really lovely lady. She lived out of state, but her aunt had left her a house because she passed away. So they've just been living the past decades.
Yeah.
They sold us their house and the cost was like the most reasonable compared to what it's ever been for the recent history of the state.
Absolutely.
And we just happened to be in the position to jump on it.
Well, that's great.
I know. And so here we are. And sometimes we still ask the question, even we are homeowners here, can we actually afford to retire? Because everything is.
It's wild. Oh, yeah. It's anywhere on the coast, can't really get away from it anywhere. It used to be like there's little pockets.
Exactly.
The circles keep closing.
We want to stay. And we want to do whatever we can to stay.
Yeah.
We know if we leave, we'll miss it. Come back.
Just something part of like the Mimbari boats and whatnot?
Well,
Because they're privately funded.
Yeah, so the Navy program used to put interns like several years ago on MBARI ships, but at the time it was before I started being the coordinator. I want to say, was it the Western Flyer or something like that? It's a ship that then got transferred into FIO, or Institute of Oceanography or FIO. Yeah. And since then, they haven't been doing it, although I just recently spoke to someone who works there. They're getting a new ship. I don't know how it's yet, but trying really hard to get that started again. Get interns again on those ships. I have visited MBARI several times. Of course, I'm close by.
Yeah.
And we want to do what we can. Right now, our grant for our program is kind of limited to UNOL's ships facilities, so foreign facilities. So we have to figure out approved ways to expand.
Yeah, absolutely.
But definitely been having conversations with MBARI and seeing if we can do that. Yeah, and they've got a lot of underwater vehicles that we can have interns work with those particular teams, and they do already host to the trips from just direct applies, people who just apply.
Those folks up there are great too. They're very, I'm pretty green to everything. I've only been in the industry for about 4 years, but everyone up there has been so kind and good people to work with.
Love to help people, to train new people, to educate and sharing, always with a smile.
Yeah.
Yeah. I don't want to lose track of time. I think.
Are we on?
Time just is
It's 10
fine.
minutes.
Oh, okay.
3:30.
3:30.
Yeah,
Okay, thank you.
Yeah.
When do we start again?
Does this stay? It doesn't bother me, but does that stay there?
Way to I apologize because there's a way to get rid of it, and I can't figure out. No, that's just the
If it's
layout.
there, that's fine. Maybe it's just on the first page.
It's on content only here. No, I don't think so. I think it will stay.
No.
Oh, Wait a minute.
Technical difficulties.
All right, Hank, you remember all your slides, right? You're just going to verbalize them.
That's right.
Wait. Okay. There is a presenter view here if you have notes.
I do.
There's a screen option here. Back soon, no. You know, I apologize because
That's fine. Let's just leave it. We don't
it's
have time to
something
mess
that I don't do this very often, moderating these things. But I wonder if there's something in here. Annotate, slide control. I don't think.
Okay. Yeah, we don't want to. We might dig ourselves in deeper.
I know. We only have a couple of minutes, no time to, try to figure all that out, huh?
We could ask, are there any technical people in the room?
Yes.
Instead of a doctor. Anything.
I know there's a way of doing it. I should ask someone.
That's fine. I'd say we just leave it there.
No,
Gives us character.
Like, please, you're scaring me. Don't do anything else.
How about that one? Can we get rid of that?
We shouldn't have to look at this. Oh, look, you're right. See, I messed it up. Okay, I know that's usually stop sharing. We'll undo it all. I'm going to do that, and then I'm going to ask somebody. No, it's not undoing it. No.
Maybe we can just slide that off the screen.
Oh, there you go. There you go.
I think we're good.
Okay.
Yeah, that works for me. Whoops, it's not advancing now.
It could be this computer. Oh, okay. How about trying like clicking right?
I think it'll.
There we go.
Okay.
Okay, I won't mess with it anymore. I'm bad luck. Okay, I'm gonna ask somebody.
All right, okay. Ready for your pre-picture here? I'm gonna stand over here.
Sure. I can update the website.
Yes.
It's two sides.
You got some padding on the back,
Well, it's just because they're connectors.
I'm gonna try one thing.
That makes sense.
No,
Okay, that's fine. I'm fine.
we've looked on the green bar and couldn't see anything. Sorry. Look what I've started now.
Nobody believes me. Okay.
Keep going. Oh, wait. Oh. Yeah, maybe just move it.
Maybe optimize hit video highlight. No.
Oh yeah, you did hide that one up there.
Oops.
No, that's okay.
So okay, and
Yep,
then
that's good.
hide floating meeting controls.
Oh,
Probably.
Can be done. All right, now we gotta do the ultimate test. Does it advance?
Yes.
All right.
So if you run into trouble with those arrows, would you be okay with just clicking right here
Yeah.
and backspace
Yep.
if you're going too fast?
Okay. Gotcha.
Thank you. Yeah, and I don't think that that's anything you're doing wrong. It's I need a new laptop. These keys.
No, I think it's fine. I just think so when we go to the generations.
Yeah,
I think we're
they're
fine.
getting stuck though, and maybe it's just maybe they're dirty or something.
Enough people touching them.
So I'm going to talk for about a half hour. This should open it up. I don't have more than a half hour things to say. But I want to get their response. Yeah, what they see, what an issue is. Sonardine gave a presentation at USPLs. You hear it?
No,
And they showed
that this
like
morning.
Sonardine. I know them better than I know them really well.
Yeah.
As a consultant. He shows massively filed views. A whole bunch of this is persistent file. But they're the only company. That's getting it. What's the deal? It's the way it is, you know. I got to stay out of the picture with the judging people. You know.
Were they showing those pictures as like an example of like
It's just like, yeah, there's a problem. There's no solution.
Yeah.
Yeah.
There's nothing we can do about this.
My first what's your
Yeah.
All the reception. Really? You go Bob?
It's on there.
Okay. Yeah. Oh, cool. Sometimes. Yeah. Okay. The red one is good less. Red is that's not good. Yeah. Yeah. Yeah, sure.
Just make a quick announcement. Okay, it's a couple of important things. Okay, everyone. Oops. Thank you for coming back. And we're going to go ahead and get started with the last breakout session for the day, but I'd like to make some important announcements. So tonight, remember, we are having our dinner at the faculty center, and I've been told that you need to have your name tag with you. So bring your name tag. You don't have to wear it the entire time, but just bring it to you. Maybe just put it in your pocket or your bag to the dinner tonight. And it's a cash only bar. Okay. The other important thing for the tours, you also need your name tag, and that's for the afternoon tours, the Scripps tours in the afternoon tomorrow. And you need to wear closed-toe shoes. So keep that in mind for those tours. And then one more announcement. No, actually, that's it. All of our students now take over.
All right, thank you very much. Hi, and welcome to our breakout session. We're going to be discussing biofouling considerations and solutions for undersea instrumentation and platforms. Just to quickly introduce myself, my name is Nico. I work at Ocean Innovations. We're a local company. We do a lot of things. I'm a bit of a jack of all trades. I get thrown into all sorts of strange situations, as I'm sure you guys do. But if you've met me before, it's probably because I did some last minute cable builds for you, or I gave you a sales pitch while you're chipping barnacles off of an instrument. But yeah, so the reason I'm here is that we manage the West Coast coding facility for ClearSignal, which we'll get into a little bit later, but that is a silicone-based coating that keeps off mussels, barnacles, and it's toxic free. And yeah, and it's Hank's company, and we're going to slowly get into that. But I will introduce Hank.
Thank you, Nico. And I feel like I've been working on all things impacted by UNOLS my whole career, and I've never been to a UNOLS meeting, but this is a great community, so thanks for having having us, Nico and I. So, yeah. Anyway, so just a little bit of background about myself. I'm an ocean engineer by training. I started a company that developed Clear Signal, which, as Nico mentioned, is a non-toxic foul release. We'll describe that biofouling control method. So we coat near the customers at these locations around the world. We learned very quickly, and we learned from scripts that they didn't really want to ship big buoys across the country. So we work with coating facilities that we train to use our processes and things of that nature. And we started about over 20 years ago with DARPA money, and we were developing biofouling control methods for the Navy Marine Mammal Program. And that morphed into developing systems for the seismic streamer industry. And with that, at the same time, we developed a coating system, all which are a little bit different for oceanographic instruments. And more lately, we just wrapped up a 3-year ONR project developing methods to control biofouling for optical instruments, cameras, the like, where they're instruments that are sensing ocean parameters or, visual cameras. So that's what we do. That's what we know. We don't know everything. We know something because we've been doing it for a while. But I thought I'd talk for about a half an hour and hopefully get some feedback from you, with your experiences, problems, if you've used our product, the good, the bad, the ugly, that kind of thing. But I want to give a more general overview of biofouling and what the selection processes are. So, yeah, a couple cases. The general case is typically ships and, floating platforms. And then there's the instrument case. And then more recently, the optical devices. So that's sort of categories we'll talk about. So just to go to real basics, right? After the coronavirus, I thought, well, not that I want to get creative, but just kind of put things in perspective. So I'm not a life science person. There's somebody out there that can correct me, right? The coronavirus is barely a living entity, right? It really isn't. Okay. And it took the best minds in the world to overcome that. That was a great achievement for, historical, technical achievement to come up with vaccines for that, but very, very primitive sort of almost life form, right? Then we have bacteria, so much sophisticated, right? Bacteria resistant drugs, sort of building blocks of all life. We're exploring outer space looking for bacteria. That would be a huge discovery. And then we have the barnacle, one of many biofouling species. This is a highly sophisticated developed, animal. And it's a very, very, very formidable opponent. So the best we can do is sort of control barnacles and other fouling species, whether it be, slimes, which are bacteria, or soft fouling, tunicates of that nature. But it's a real battle. And these are, pretty adaptive critters. And Darwin himself said something to the effect, I hate nothing more than I hate barnacles, right? Darwin himself. So anyway, just to kind of get in the mood to talk about biofouling, we started in aquaculture. That's an aquaculture net. That's a deep diving AUV. The problem was it got stuck on the surface as loitering, so it's no longer deep diving. It's susceptible to biofouling. That's one of the Scripps buoys under the worst case scenario, and that's a lot of fouling. And as you can imagine, that's causing a lot of problems, both weight, safety, and also performance. We'll talk about that a little bit. So that's an oxygen sensor covered up in barnacles. Another picture of a Scripps buoy. And there's another AUV. This is one of the OOI AUVs that deployed out of Woods Hole. It too became disabled on the surface. And once you're able to get control back of your vehicle, if biofouling sets in, you're not really going anywhere for this particular case of AUVs. So where's biofouling in the list of problems? Well, it's become more prominent because, as you know, memory's gotten a lot better. Electronics have gotten a lot better, a lot lower power. So our batteries last longer. And also memory has gotten, much, much better and much, much cheaper. So those sort of electronic strangleholds aren't really the problem now. The limiting factor for deployment times is often, not always, often biofouling. And so I will tell you this about biofouling technology. We're the only technology that moves slower than batteries. So we inch along. So the general case for biofouling is you either use biocides, which are poisons that kill things, or you use non-stick coatings, the fancy name for which foul release. So traditional paints, which are typically used on vessels and not typically used on instruments, and we'll go into that a little deeper. So there's copper-based, metal-based biocides, and there's a new classification of biocides based on herbicides called, the commercial name is Echinacea. And the paint matrices that release these biocides to control how much poison gets emitted to the surface of the painted device that, whether it's a ship or whatever else, that's become fairly sophisticated over the years. But there are limitations. So on the left bottom is the only picture I could find of a can of TBT paint, which is tributyl tin, and that was the gold standard till it was outlawed worldwide. So this stuff is so soluble, if you touch it, you can actually, it'll absorb into your skin and you can almost taste it. So it's really, really good biocide, not used anywhere in the world now. The US Navy used to use it, and that drove a lot of their research, some of which we use to develop our product line. Then on the bottom right is copper coat, which is a heavily laden, non-ablative coating that's used on some autonomous surface vehicles, such as the Wave Glider, and I think a couple other ones. And it's not a bad solution, right? It has some attributes. But again, I just want to point out kind of what the whole gamut of the biofouling sort of technologies are. So got biocides and you have foul release. So foul release is non-stick, non-toxic. There's some advantages. Two companies that produce something for instruments are ourselves, which is the Clear Signal. It's sprayed on in our facilities. And then there's something called Marine Glide by the Nitto company. And if you look, Nortec offers these little patches which you could put on there. So it's nice because it's user applied. If you want our coating, you have to send the instrument to us. There's a disadvantage to the Nitto. It's a pressure sensitive adhesive and the organisms will bore in the sides. You can't cover, non-flat surfaces, but it's a very cleverly designed technology. And, we just want to note that it's out there. It's one of the choices. So on the bottom are silicone or foul release bottom paints for ships. And they're used by a certain segment of the shipping industry, not as widely used as they were perceived to be during the early development of these coatings, or perceived to would become. Anyway, other sort of approaches are copper cladding. Some of the labs you'll see, copper tape, wrapped around. That's sort of a mild sort of approach. It's not very effective. It's probably better than doing nothing. And also on the left there, that's copper cladding on a, what could be an H of both. This has been going on for a couple thousand years, as an option. So I don't know if the Seabird person is here or not. Seabird has a TBT pill, right, that they actually have a license from the EPA to use. So they're the only company allowed to use that. And that protects the flow through sensor of their devices. So Seabird does not do anything for the housing section of their device. And they're sort of a poster child for a device that can be fouled because there's so much turbulence caused by the outer sections of their housings. This was a newer approach, and sometimes the very sort of creative and what you might think high-tech approaches for biofouling control are the least effective. So this was something that came out of University of Florida. It's a very textured surface. It has sort of microbial resistance, which are the early stages of biofouling. As soon as you put it in water, it becomes contaminated. It just doesn't work. Its surface topography goes, it just doesn't maintain its original topography. So it's used in hospitals and things like that. It has never found a place in the marine biofouling protection world. And then we have home remedies, my favorite. So tape is good, right? But it's tape, so it's temporary. So it'll protect what you have for a while, and then you take the tape off, or saran wrap, and then any number of greases, Desitin, whatever, right? And those are ablative, and eventually they wear off, but they will provide some protection for a short period of time. And then the closer you get to Gulf of Mexico, this is true. Any Tabasco or pepper sauce added to that is a plus, right? There's no scientific evidence to support that. It's really just the ablative properties of the Carisha apply it to. But, I wouldn't make this statement down in Texas, Louisiana. They just wouldn't accept it. So anyway, so what's the advantage of foul release? Well, if you have a biocide, it leaches out anywhere from 6 months. The very, very best, most sophisticated paints, maybe a year and a half, something like that. Whereas foul release, it maintains its efficacy over the life of the coating. If the coating is designed properly, that lasts the life of the instrument. So for long-term deployments, you're really looking at foul release. You put copper paint on an RDI instrument or anybody, they're not even going to accept it for service or anything like that, the companies that make any particular instrument. So that's kind of where we are with instruments. It's all about foul release. Another thing that you wouldn't think of, and this is especially true with the oil and gas industry that we serve, is toxicity. So there's no human health risk. And to be honest, there isn't much with copper paint, right? But, the HSC or health safety environment is a big deal for our oil and gas community. So that's another reason they're attracted to foul release. So in the instrument world, most people that use foul release on instruments, the large majority use our product. And then the large majority that use foul release for shipping is International Paint and some combination of another company, Hempel Paint. Both are, products that are designed specifically for ships and can work very well. So this is the crux of everything we do engineering. So this is in millipascals. I can't think in millipascals. This is a work that was done by Florida Institute of Technology on the adhesion of barnacles to different substrates. So here's the PSI version of that, right? So if you take CP bronze is something that's sitting in the water and getting fouled. To remove a barnacle, it takes about 350 PSI. And then you see clear signal there, which is representative of number of silicone coatings. That number goes down to about 5 PSI. So it's, more than an order of magnitude difference. And that's what this is all about. So if you can imagine, this is a coated multi-beam, right? So you want low adhesion resistance to the outside to the animals. But the hard part in all our engineering, I mean, all of it almost, goes to getting good adhesion to the substrate. So this particular instrument, and this is representative of the industry at large, right? This is titanium shell with a polyurethane transducer potting compound. And then there's a Delrin plate that goes inside here, polyacetal. All those take different formulations to achieve adhesion to those substrates and different surface preparation techniques. So if you put a foul release coating on an instrument like this and the coating delaminates, you go from 5 PSI adhesion for the animals back to 300. Or if you put copper paint on here, right, which you wouldn't normally do for an instrument, and all the biocide leaches out, right? Now you went from, basically 0 PSI to 300 PSI. So that's the issue. And the shortcoming of foul release coatings has been adhesion to all these different substrates that occur in the world we live in with instruments. So you're talking, all different types of metals, all different types of paints, a variety of different plastics, right? So the list goes on. So the way that we combat that is we have a sample of each substrate we coat. And so we coat a sample, we breach the surface of it with a knife, we immerse it for about a month, then we send it out for independent sort of environmental exposure, and then we maintain a time series of immersion of all these pieces. So we have, hundreds of these things in water that's been going on for the last 20 years. And that way we can see what works and what doesn't work. So as we were learning and as we started, we would send out instruments that would delaminate, right? The coating would, it would fail. And we have to go back. So over time, lessons learned, all these good things, right? We have it right. Every now and then something comes along, a very odd situation. But you know, in general, and it's sort of the hallmark of this world, right? Everything's a niche application and they're very, you know, the sales quantities are very small. So it takes a lot of dedication and a lot of sort of business craftsmanship to keep this going. But, you know, it's, you know, the journey's been great and hopefully we're helping the community. So this is an example of one of the buoys that we coated. And as you can see the picture in the bottom, that's real world what happens. The coating's going to get breached, right? So no coating is tough enough to withstand everything. Most failures occur in shear, something's moving sideways. So the object here with the foul release coating is that failure will not propagate. If it does, then it's all going to delaminate. And then you go from that 5 PSI adhesion back to 300. So that is a fairly difficult thing to achieve, but that's what it takes to keep this stuff working. So, and just an example, this is a deployment from Scripps here, the buoy group that we do quite a lot with. So they put a coated system out and an uncoated system out at the same time, left them out for 2 years. And the copper coated, once again, not to repeat myself, all the buy side leached out, you're back to that high adhesion, full of barnacles, and the, you know, foul release coated unit comes back clean. So to that point, let me see. Buoys are particularly suitable for foul release. As they heave up and down, they end up being self-cleaning most of the time. I was up at the lab today, they showed me a buoy that had clear signal coating and it sort of was half clean because the fouling pressure was so intense. So that's the first time we've seen that. So again, live and learn. But in general, it's just a great application. Another application where the coatings are self-cleaning is seismic streamers. These streamers are moving through the water, being towed about 6 knots, and they tend to get gooseneck barnacles, which have sort of they grow outwardly, and they have a lot of profile in the water, and they are completely self-cleaning. So, in general, if you put that was on a buoy also, so that's an Endura instrument, also pretty much self-cleaning. There is no magic bullet for biofouling control. If you put a foul release coating on an instrument that's static in the water, in time it will accumulate a certain amount of biofouling. And the object there is, again, you've reduced the adhesion from about 300 to 5, that it's easy to clean. And so there are different strategies to do that, either with divers, ROVs, water jets, and the idea is to build a schedule around that. So another application, this is, that's a 38 kilohertz ADCP that Shell had deployed for a number of years. So there's a little bit of fouling accumulation in the middle of the instrument. The edges of the instrument are not coated, and there's another factor I'll discuss that's causing more fouling there. But it's, by and large, controlling fouling in a static situation, so you're getting less accumulation and, again, easier cleaning, but not 100% full, you know, again, not, it takes some strategy to keep this clean. So again, foul release coatings offer long-term protection. It's really the only approach. And the important thing is the adhesion to the substrate. And when that adhesion to the substrate is not sort of pre-tested and really vetted, then problems occur. So another factor, streamlining. Often things are put in the water with surfaces that have discontinuities. And you can see the picture on the right, that's flow that's separated. That's a low pressure area. That's sort of getting out of the wind for fouling organisms. That's where things really start to accumulate. And often there's no consideration given to streamlining. So, you know, on the bottom is a streamlined body. That's sort of the ideal case. And what are the real results of that? So there's a typical buoy, not very streamlined. If you look, same picture, right? The edge of that ADCP has a crack between the shell and the transducer area, and that little gap is enough to cause enough flow separation for barnacles to settle in there and start growing. That's exactly what happened there. This was the Rutgers glider that crossed the Atlantic about 15 years ago. We coded that, which is one reason they made it across. We did not give enough separate consideration to the separation between sections and the little gap there. All the fouling occurred where the sections were put together. So subsequent to this, we came up with a system to tape up those gaps and tape and coat over the tape. So another lesson learned. I mean, it just it never stops, you know. Nature sort of wins. We had instances where we had delamination because of UV, and UV was penetrating the water enough on some of our instruments that were at 10 meters and things like that. We had to redesign the coating and protect against UV. But we, again, you know, trained ocean engineers think we know what we're doing, and then, you know, got caught again. But, you know, over time, these things rear their ugly heads and you solve the problem. So we were coding shark tags for a long time and working with the manufacturer of wildlife computers on how to streamline those tags so they would accumulate less value. We did the same with some of our seismic streamer customers, working with them to streamline the connection points of the seismic streamers. Whole new class of materials that I mentioned earlier, we did some work with the Navy on over the last 3 years, are optical systems. So cameras have been around forever. There are new optical communication systems for high data rate communication through water that will become more prevalent. They're not widely used now. If they're used in deep water, they're not likely to have a fouling problem. If they're used in shallow water, they're very likely to have a shallow fouling problem. So our Navy program was to develop a coating for optically clear substrates and also another method, because as we said, if we put things in the water in a static condition, it's going to accumulate fouling. As you can imagine, an optical system just needs a little bit of bacterial settlement to be disruptive. I mean, that's not going to bother an ADCP or any type of acoustic instrument, but the optical instruments are, you know, for obvious reasons, very sensitive to a little bit of fouling. So some of the early approaches, this is actually a good device. The company AML makes it. It's an externally mounted UV device. So UV sterilization to kill early growth on optical instruments. And it has seen some use. And wipers on this type of sonde instrument. But here's what happened to wipers, right? Gets fouled. Same with the AML device. It's external. So, you know, how far you want to take this? Something to clean the wiper? I mean, it'll go on forever. So that was a device that used liquid immersion to sterilize optical sensors, which was never commercialized, but is a valid concept. And this is what we developed. So we had a team of Florida Institute of Technology for the biology end, the company Arctic Rays, which you may or may not be familiar with. They're a very sophisticated camera and light development and company that offered commercial products. They were recently acquired by Inkfish, who are similar to Smith. They own a series and are building a series of ships for oceanographic research. So they're no longer in the commercial product business, but they helped us develop a system that consisted of an optical window that had a very clear optical sort of variant of clear signal on it, right? And LEDs that are mounted inside the camera case. So the LEDs are now immune from the outside environment and fouling. And so this approach of UV has been tried before. What we were able to do is quantify the correct wavelength, duty cycle, characterize the amount of power required, right? And we did a whole bunch of biological testing, a couple of years worth that Florida Institute of Technology ran for us. And we had very good results. So we could extend the life of an underwater camera by the deployment times by 5 or 10 times the normal amount. And we probably tweaked this to about, you know, sort of a 70% level. So we have, you know, more improvements to make. We are not in the electronics business. And I mentioned Inkfish, who acquired um, Arctic Rays, right, who really developed this for us, are not interested in commercializing it. So this year we'll be publishing a paper with FIT teaching the community at large how to build these. And that's a better solution for the community because this has to be integrated by the camera and light manufacturers during the manufacturing process. So that it's almost impossible for somebody that owns this technology to make it available to all the different manufacturers. This is just a much cleaner solution and one that we think benefits the community at large. I'm sorry. Yeah, so we had controls and coded. Yeah, it was just, yeah, I didn't want to go into the whole sort of test array, but we had coded windows and uncoded windows, and windows with UV and without UV. As you can imagine, it was like every other experiment, it got out of control. So we tried to limit anyway. So this is promising, and to our knowledge, this is the first time sort of a systematic series of this type has been done. There's been other UV work done, but not to the degree of this. So, ONR saw a reason to pursue this and did, and it's turned out pretty well. So conclusions, okay, for things like undersea lighting, it's all about an integrated solution. Even for non-optical, it's really about an integrated solution. If it's a buoy, it's self-cleaning and heave or a seismic streamer. That's another sort of forcing function that's making this, possible to be a usable device in the water for a longer time. And then, as I mentioned, other intervention techniques, have to be implemented, either divers, ROVs, water jets, whatever it might be. But these things, even all things immersed need some level of maintenance. It's just a question of how often and what's required for the actual environment the immersion takes place. And yeah, the other take home from this, it's streamlining and picking the right solution for the application yields really, really big results. It's just so easy to increase deployment times by 2 or 3 or 10 times. Just as an example, the buoys that are deployed by Scripps were unusable after 2 years. Now they're completely, in most cases, clean after 2 years. And now the limiting factor for those buoys, we're back to batteries. It's not the biofouling anymore. So that's a good thing for them. And they're going, far places to recover these buoys. And then another consideration for fouling in general is obviously data. So a wave buoy that's moving up and down and being measured with accelerometers is going to be impacted by added extra mass. Acoustic instruments are fairly resistant to biofouling, but in time, you lose range, accuracy, those kinds of things. And anyway, thank you. And that sort of covers most of it.
Yeah, and before we get to questions, I just wanted to show some pictures of coded instruments. It goes beyond just buoys. We've been doing so this is the CDIP program up the hill here. So not only are they coding their buoys and their sensors, but they're also coding the chains, their triangles, everything in the system that they use is coded because, like how Hank showed, any weak point is going to get taken down by barnacles. And then I wanted to show a few different ADCPs that we've been coding. It's just kind of a good thing to show, like, post coding. It actually, makes these instruments look beautiful, in my opinion. But yeah, up in the left-hand corner, you have a Workhorse ACP, and then we have a Nortec instrument. We have a Pinnacle 45, and then in the middle there we have the new Proteus, which Teledyne just came out with. And then, yeah, I just want to show one thing. And we're at Script Spear here. So there is a camera, live stream camera under Script Spear that's coated with clear signal, and it also pairs with a UV camera. And 50/50, this works. All right. So this is live on the script here right now. And, it's just kind of a show you that, biofouling solutions at work. This is a biofile rich area. As you can see, the script pylons with, lobsters living on them and whatnot. But yeah, this is a technique that's used both clear signal and UV. So yeah, we'll open up to questions right now as you have a nice view of the ocean.
Any biofouling experience you can share, good for us.
Blink worked.
So where are you guys, applications for boats themselves? If we can't get I'm thinking for a vessel that I run back in May, we have a couple of side scan sonars, transducers, hull mounted, that I just pull piles of mussels and barnacles all off. This is a boat that moves a fair bit. So, to be honest, was a little bit surprised when quick I pull a football size chunk of mussels off. What could be done to solve that problem for us?
On the instruments, the hull mounted?
Yeah, on the hull mounted.
Yeah, so that's what we do for a living. So, most of these multi-beams that we coat, and a lot of them, right? And
well, I guess,
but you have to
install.
Yeah, you have to pull the instrument off the vessel and send it to us. So the way that we achieve good adhesion is to apply our coating in a very controlled environment. So it's not user applied. Yeah, but yep.
Have you considered mobilizing your controlled environment to somewhere like a dry dock or?
We've looked at it. Yeah, it was boy, it might have been one of the ships came in with one of the really large Kongsberg multi-beams, and it was going to be very, very expensive. It was going to be, normally that would cost, take a guess, $5,000 or $6,000, a really big multi-beam. This was going to be $25,000. So the user didn't want to do that. It is possible, but it would have to be sort of a more extreme circumstance, I guess.
Just out of curiosity, have you been used the coating with the Zeus beacons, like the VHF beacons?
Yes, we're coding some as we speak. Yeah.
What's the idea? Like, how long should it last?
It should last the life of the instrument. So, in general, instruments seem to get pretty banged up after 5 or 6 years, and they're coming in for reservice anyway. So that's sort of the time frames we're working on.
Yeah, my question is, we're having some intermittence with especially with the VHF beacons. Sometimes we recover it and it was done. So it was falling.
Yeah. So we've had really good feedback from the beacons we've coded are mostly about just getting a visual light flash, but I'd have to look back and see how many had sort of VHF or whatever radio or sort of apparatus in as well. But we've had good feedback. And most of those we've done for the manufacturer, and they're sending them off to the customer. So when there's a problem, we hear about it. As with everything, right? If there's no problem, occasionally we get a, hey, everything's working well, but that's not usually the case. So.
Going back to this coating in the dry dock,
So you were saying a full-size vessel, and did you actually say $25,000?
No, not for the vessel, just for the multi-beam component. Yeah, because we'd have to mobilize people from a very sophisticated paint facility to go, to a shipyard and set up.
Money to me. That should last the life of the. How many years? You think that's good for 5, 8, 10 years?
Yes.
That's
Yeah.
cheap to me.
Yep. Okay.
So on Dawes Last Shipyard, Nick and I spent 5 entire days scraping the couple hundred square foot gondola. It was the nastiest we've ever seen it. And what we've traditionally done is just in a really thin light coat of the same anti-fouling paint that goes across the entire hull. And I don't want to do this again. It was miserable. We were on creeper crawlers too because the gondola was less than 2 feet off the bottom of the dry dock. Anyway, sorry to stop with the whole horror story, but
no, we like those.
We
like the horror stories. Yeah.
We're talking about a couple hundred square foot, and whether we get into that is the cost worth it or not to clear signal. What do you recommend for the best application when you really only have a couple of days between the multi-beam ADCPs, whatever, are clean and dry, and the ship is going to splash again? And the last thing I want to say is that we installed an SVP 70 that you guys clear signal coded for us. Thank you on that dry dock, and it's currently underneath the ship. And so when we pull it out in a year and a half, we'll definitely let you know how it fared. But
okay,
we're very hopeful it's going to do a lot better.
Okay, that sounds good. So I guess was your question, what should you do if you only have a day turnaround or something like that?
5 days, right?
Yeah.
And we're talking about something that's large in the scale to the bottom of the ship. What do you think is the best method?
You're sort of stuck with bottom paint, because it's just, the application for something that we would do is going to take a lot longer than that. And we've actually never done it, so we'd have to figure it out. So, and the bottom paint will buy a year, but yeah.
Are there any considerations for this application with pressure or like at depth? A lot of these theory things are surface, but if you're talking about putting things like to deep depths or cameras staying down there for a while, is there any other like pressure consideration for you guys, or is it
For pressure as in depth or as in water jetting or something like that?
things that are gonna directly on the sea floor and trying to not interfere with scientific equipment or
So I just want to understand, is it about the depth of the water or the pressure of the water?
yeah,
No. The coatings, the density of water, there's no factor or consideration there. The only thing that could happen if the coating wasn't stable, it could possibly delaminate from moving around a little bit, but we designed against that. So that is really not an issue. We actually had UW test at depth on hydrothermal vents. I don't know how deep it was, 5,000 meters, some crazy depth, but we've had others, pressure tests for different applications, and just it's the one thing that's never been a factor. Yeah.
Like a precedent for installation, right? Because the multi-beam is pretty big, so you're going to have to push it up, and right.
Yeah, I just don't think it's a factor because with any instrument, you're going to take sort of all the measures you can to protect it because they're not delicate, but there's a limit to how not delicate they are. So I just even with large multi beams, just don't see an issue. I mean, the coating is really robust. So if you have it on, say, some kind of lift system and it's being lifted up and it's bearing its own weight, it's not going to be a problem. So more than any other painted surface. So
Was it all coated as one unit, or was it the individual transducer elements coated? I'm curious.
No, it's a small instrument this big. Yeah, so we sent it in. Yeah, it just tells the sound speed, velocity.
Oh, we're not speaking. Not this.
No, not NP.
Oh, okay, and so if we were if you were to coat, transducer element, each transducer element would need to be coated, is that correct?
I'm sorry.
Each transducer element.
Yeah, we tend to coat the whole face. So we recommend, you have an instrument, it's got a housing and it's got a head and it's got transducers, integrated into the head. So at the very least, you want to coat the transducers. We recommend coating the whole head and the whole body. So if you get fouling, the biggest component of surface area is the housing itself, right? Typically. And that biofouling will start on the housing, the larger surface area, then propagate its way to the sensor area. Yes. Well, depends what you call large, but 38 kilohertz ADCP is pretty large. And we have not done, for instance, Kongsberg, the large arrays, we have not done those. But yeah, I mean, we prefer to have things sent to us, and there's no limit to the size that we can handle in our facilities. And again, as we were talking about, doing things in the shipyard is something that we'll further investigate when we get another request for that.
I have a question. Have you engaged in conversations with the vendors of these modules to pre-coat them before they're delivered?
Yes. So Norbit, one of the multi-beam companies, coats in-house under license, and Teledyne Rezon started coating in-house under license early 2025. We talked to Kongsberg about it. That may or may not happen. And we're one of the coating facilities is in Houston, which is very close to R2 Sonics. So we provide the coating for them. And that's on a customer request basis. But our goal is to serve the customer. So if we could be an OEM add-on, that's our preferred method of doing business. So that's what we're always trying to strive for, is to have the manufacturers provide that directly. Yeah.
The multi-beam consists of a bunch of somewhat smaller transducers, but you mentioned the gaps and stuff fills in those little gaps if they're not coated well. That could be a problem. Not done for the whole transducer, but and also we have ADCPs that are behind plexiglass windows. And I'm wondering, you coat the plexiglass window, that's the part that's actually flush with the outside of the ship. Again, we have an edge, so I don't know how we do with that, but it sounds really good. It sounds like we should be pursuing this.
Mm-hmm.
If we in some cases and see what we can do. And I don't know, start that small and
yeah, there's a lot of times where you're not going to be able to get around the edge. I mean, if there's there are often engineering solutions, putting more of a radius on anything helps a lot. In fact, we were just looking, the buoys, the script buoys that we saw up here a couple of times, they're two pieces that have a really sharp edge in the middle, a flange. And so we were sort of looking at that today, thinking a way to sort of, add radius to those edges. But to do nothing is the worst case. So let's say you coat the plexiglass. You've really addressed a large portion of the problem and can assess from there. But to answer your question, yeah, we can coat the plexi. That's one of the things we can coat. We've actually had customers that coated the transducer when it's in a well and it's not exposed to seawater. And we said, you don't have to do that. And they said, we want to do it anyway. Said, okay. But, yeah. But equate this, not to go off on a tangent. It's almost like renewable energy. If you combine two or three things, you can really, modern day technology provides real solutions. And same thing there are combinations of things for biofouling control that are largely not adopted, that are there to be adopted. So there's real potential for improvement. Going once, going twice. Okay. All right. Well, thank you, everybody. That was good. Usually I stay with this one.